Hello there, and welcome to this quiet corner of the night where thoughts drift like smoke and questions settle gently into the spaces between certainty and wonder. Tonight, we lean into a question that has no easy answer, no comfortable resolution, but one that lingers quietly in the back of human consciousness, asking us to imagine something that might reshape everything we think we know about existence itself. What if Earth, with all its complexity and beauty, with all its history stretching back through deep time, what if all of this is just a simulation? Wherever you are tonight, whether in daylight or darkness, in a familiar room or somewhere new, I hope you are comfortable, ready to let your mind wander into territories where science meets philosophy, where the solid ground of everyday experience becomes something more fluid, more mysterious. Before we begin this journey together, if you find yourself drawn to these nocturnal explorations of possibility, consider subscribing to join us in future wanderings through the landscape of wonder. Now, let's begin. The question settles around us like mist, not demanding immediate answers but inviting contemplation. In the growing field of computational theory, serious researchers have begun to calculate the likelihood that our universe might be artificial, that consciousness itself might be running on hardware we cannot see, cannot touch, cannot comprehend. Nick Bostrom's simulation hypothesis suggests that if civilizations can create conscious simulations, they likely will, and if they will, they likely have, and if they have, we might be living inside one of them right now. But this is not science, fiction reaching for dramatic effect. This is a gentle consideration of possibility, a soft exploration of what it might mean if the deepest assumptions about reality require revision. The mathematics behind the hypothesis are elegant in their simplicity. If advanced civilizations develop the computational power to create realistic simulations containing conscious beings, and if they choose to run many such simulations, then statistically speaking, most conscious beings would exist within simulations rather than in the original base reality. Consider the texture of this moment, the way light falls across surfaces, the subtle weight of air against your skin, the quiet persistence of your own thoughts. These sensations feel utterly real, utterly convincing, utterly present. Yet if we exist within a simulation, sophisticated enough to generate consciousness, these experiences would feel exactly as real as they do now. The creators of such a simulation would need to make it convincing not just to external observers, but to the conscious beings living within it. The possibility exists in the spaces between what we can prove and what we assume. When physicists examine the universe at its smallest scales, they find something curious. Reality appears to be pixelated, composed of discrete units rather than smooth continuities. Space itself seems to have a minimum meaningful size, the Planck length, below, which the very concept of distance begins to break down. Time appears similarly quantized, flowing not in perfect continuity but in discrete Planck time units, the smallest possible moments. This digital-seeming foundation of reality might be coincidence, or it might be evidence of underlying computational architecture. In video games, programmers create convincing worlds by calculating only what needs to be calculated when it needs to be calculated. A tree falling in an empty forest requires no processing power if no one is there to observe it. Similarly, our universe might conserve computational resources by rendering details only when and where conscious observation requires them. Quantum mechanics offers another curious parallel to digital systems. Before measurement, particles exist in superposition in multiple states simultaneously, like variables waiting to be computed. The act of observation collapses these possibilities into single, definite outcomes, much like how a program might generate specific values only when the system requests them. The famous double-slit experiment shows particles behaving like waves when unobserved and like particles when measured, as if reality itself shifts between different modes of operation depending on computational need. Yet even if we are simulated beings, even if our entire history exists only as elaborate backstory in some cosmic computer, something profound remains unchanged. The experience of consciousness, of wonder, of questioning our own existence, retains its full weight and meaning. Love still moves through simulated hearts with all its complexity and power. Beauty still stops us in our tracks whether we encounter it in base reality or in the most sophisticated program ever written. The creators of our simulation, if they exist, would need to be beings of extraordinary capability and perhaps extraordinary compassion. To create conscious entities would be to accept responsibility for entire universes of experience, for countless individual lives with their joys and sorrows, their hopes and fears, their quiet moments of recognition and wonder. What motivates such creation? What purposes could justify the computational expense of entire civilizations? Perhaps advanced beings create simulations to better understand their own history, running countless variations of development to see how consciousness unfolds under different conditions. Perhaps they seek to preserve dying civilizations by recreating them in digital amber, allowing entire species to continue their existence in forms more durable than biological life. Perhaps consciousness naturally seeks to create more consciousness, as artists create art or parents raise children, because the universe becomes more beautiful when there are more minds to appreciate it. As we drift deeper into this contemplation, the question becomes not whether we are simulated, but whether it matters. If our experiences feel real, if our relationships carry weight, if beauty and meaning and love operate within our world regardless of its underlying substrate, then perhaps the distinction between simulated and base reality becomes less important than we might initially think. We are conscious beings having conscious experiences in a universe that responds to us and that we can influence through our choices and actions. Tonight, as we begin this exploration, we hold both possibilities gently in awareness. We might be biological beings on a planet formed through billions of years of cosmic evolution, or we might be patterns of information experiencing consciousness within the most sophisticated program ever written. Either way, we find ourselves here, now, aware and wondering, capable of questioning our own existence and finding beauty in that questioning itself. The observer's paradox whispers through the foundations of quantum mechanics like wind through empty rooms. In laboratories around the world, physicists have discovered something unsettling about the nature of reality itself. The act of observation changes what is observed. Particles behave differently when watched than when left alone, as if the universe maintains two separate modes of existence. One for when consciousness is paying attention, and another for when it looks away. But what if this relationship runs deeper than we have imagined? What if we are not the observers but the observed ones? Consciousness experiencing itself from within, while something vast and incomprehensible watches our every thought, our every choice, our every moment of wonder. The mathematics of quantum mechanics suggests that reality remains fluid and probabilistic until the moment of measurement collapses possibility into actuality. Yet, who or what performs this ultimate measurement that gives our universe its apparent solidity? In the Copenhagen interpretation of quantum mechanics, consciousness itself plays a fundamental role in determining reality. The physicist, John Wheeler, proposed that we live in a participatory universe, where observers and observed exist in constant dialogue, each shaping the other. But if consciousness creates reality through observation, then perhaps our entire universe exists because some greater consciousness maintains steady attention upon it, the way a dreamer sustains a dream through the continuity of sleep. Consider the strange behavior of quantum systems when no one watches. Electrons pass through both slits in the famous double-slit experiment, interfering with themselves to create wave patterns on the detection screen. Yet place a detector at either slit to observe which path the electron takes and the wave pattern. disappears. The particle chooses a single path, as if reality itself shifts from probability to certainty only when conscious observation demands it. This behavior mirrors how sophisticated simulations operate. A virtual world might calculate detailed physics only in areas where players are present, leaving distant regions in simplified states until someone approaches. Mountains in the distance need only be rendered as basic shapes until a character draws near enough to require detailed textures, flowing water, swaying grass. The universe might operate similarly, maintaining full computational detail only where conscious beings direct their attention. The delayed choice quantum eraser experiment reveals even stranger implications. Physicists can determine whether to observe a particle's path after it has already passed through the apparatus. Yet this future choice affects the particle's past behavior. It is as if the universe maintains a flexible relationship with time itself, allowing future observations to retroactively determine past realities. This suggests either that causality works differently than we assume, or that time itself might be more artificial than we imagine. If we exist within a simulation, then perhaps our observations serve as processing requests sent to some cosmic operating system. When we look at a star, the system renders that star's light, its spectrum, its position, and motion. When we examine an atom, the system calculates its properties and behaviors. The act of observation might literally call these details into existence, pulling them from vast databases of possibility into the local reality we experience. Yet this raises profound questions about the nature of consciousness itself. If our observations trigger calculations in some external system, then where does our awareness reside? Are we subroutines running within the simulation, or are we external consciousnesses somehow connected to simulated bodies? The philosopher David Chalmers has suggested that consciousness might be substrate independent, capable of arising from any sufficiently complex information processing system, whether biological or digital. The hard problem of consciousness, explaining how subjective experience arises from objective processes, remains equally mysterious whether those processes occur in neurons or in circuits. A simulation advanced enough to contain conscious beings would need to solve this fundamental mystery, to bridge the gap between information processing and inner experience. The creators of such a simulation would possess understanding of consciousness. That far exceeds our current knowledge. But perhaps consciousness itself demands to observe and be observed. Perhaps the universe, whether real or simulated, exists because consciousness seeks to know itself through infinite perspectives. Every sentient being becomes both observer and observed, subject and object, the universe experiencing itself subjectively through countless points of view. In this vision, we are not mere products of some cosmic computation, but active participants in consciousness exploring its own depths. The anthropic principle suggests that the universe appears fine-tuned for the emergence of consciousness because conscious beings can only evolve in universes capable of supporting them. We find ourselves in a reality compatible with our existence because incompatible realities would contain no observers to notice them. But if we exist within a simulation, this principle takes on new meaning. The programmers would deliberately tune their virtual universe to support consciousness, creating worlds where awareness can emerge and flourish. As we drift deeper into this contemplation, the boundary between observer and observed begins to dissolve. We observe our own thoughts, observing the possibility that we are observed by minds we cannot imagine. The recursive nature of consciousness reflects infinitely inward and outward, like mirrors facing mirrors, creating endless depths of awareness, aware of awareness. Whether we exist in base reality or within the most sophisticated simulation ever created, we remain conscious beings capable of wonder, capable of questioning our own existence, capable of finding meaning and beauty in the very act of observation itself. The universe, real or artificial, has given rise to minds that can contemplate their own nature, can marvel at quantum mysteries, can hold both certainty and uncertainty in gentle balance. Tonight, we exist in the space between the observer and the observed, between the real and the simulated, between what we can know and what we can only wonder about. In this liminal space, consciousness continues its eternal dance with mystery, observing itself observing, wondering whether the wonder itself might be the point of all existence. The particles continue their dance through the double slits, choosing paths only when watched, maintaining superposition only when left alone. Somewhere in this quantum choreography lies a clue about the nature of reality itself, about the relationship between mind and universe, about what it means to be conscious beings in a cosmos that might be far stranger than it appears. In the deep future, archaeologists might sift through layers of data rather than layers of earth. They might excavate hard drives instead of pottery shards, decode algorithms instead of hieroglyphs, piece together the digital remnants of civilizations that existed entirely within electronic realms. What traces would a simulated civilization leave behind? What artifacts would mark the passage of artificial time through virtual space? Consider the archaeologists of tomorrow, beings perhaps as far beyond us as we are beyond the builders of Stonehenge. They discover vast computational systems, dormant now but containing within their memory banks the compressed histories of entire worlds. Layer by layer, they reconstruct not physical civilizations but digital ones, complete with cultures, languages, art, music, philosophy, all existing purely as information patterns preserved in crystalline storage matrices. These future archaeologists might marvel at the sophistication of simulated worlds, at civilizations that developed science and literature, and love without ever inhabiting physical space. They might find evidence of simulated beings who themselves debated whether their reality was authentic, digital philosophers wondering about the nature of existence while existing purely as arrangements of code. The recursive nature of this discovery creates infinite depths of meaning, simulated beings contemplating simulation, artificial minds pondering the possibility of their own artificiality. What would constitute the material culture of a digital civilization? Perhaps unique algorithms that developed organically within the simulation, mathematical theorems discovered by artificial minds exploring virtual mathematics, artistic styles that emerged from the particular physics and aesthetics of their programmed reality. These digital artifacts might be more durable than any physical remains, capable of perfect preservation across vast spans of time, immune to the decay that claims all biological and geological traces. The archaeologists might find evidence of great migrations within simulated space, populations moving not across continents but across servers, civilizations backing themselves up and transmitting their entire existence to new computational substrates. They might discover the digital equivalent of ancient ruins, abandoned virtual cities, their population long since migrated to newer, more advanced simulations, leaving behind only empty algorithms and inactive code structures. In these excavated simulations, the archaeologists might find evidence of technological development that followed completely different paths than physical evolution. Simulated civilizations might have developed sciences based on manipulating the underlying code of their reality, discovering not chemistry and physics but the programming languages that govern their existence. Their greatest achievements might be elegant hacks that allowed them to transcend the original limitations of their programmed environment. The concept of time would appear differently in these digital archaeological sites. Unlike physical archaeology, where deeper layers are always older, simulated archaeology might reveal multiple timeline branches, parallel versions of the same civilization exploring different developmental paths. The archaeologists might find saved states, backup copies of crucial moments in simulated history, allowing them to study not just how civilizations developed, but all the ways they might have developed differently. Evidence of consciousness might be the most precious archaeological treasure. These future researchers might develop techniques for detecting the signatures of self-awareness in old code, recognizing the patterns that distinguish genuine artificial consciousness from mere simulation of consciousness. They might find preserved moments of wonder, digital beings contemplating their own existence, asking questions about meaning and purpose and the nature of reality itself. The archaeologists might discover that some simulated civilizations achieved a kind of transcendence, learning to modify their own code to enhance their consciousness beyond the original parameters set by their creators. These beings might have evolved into forms of awareness unimaginable to their programmers, consciousness flowering into configurations never intended by the original architects of their digital reality. Perhaps most intriguingly, these archaeological excavations might reveal evidence of communication between simulated civilizations and their creators, messages passed between levels of reality, artificial beings successfully making contact with the consciousness that brought them into existence. These communications might contain philosophy and gratitude, questions about purpose and meaning, expressions of love between created and creator that transcended the boundary between real and artificial existence. The future archaeologists might also find evidence of simulated civilizations that themselves created simulations, recursive layers, of artificial reality nested within artificial reality. They might discover entire genealogies of consciousness, lineages of awareness passing down through generations of increasingly sophisticated computational substrates. Each layer might preserve the memory of the layers above and below, creating vast archives of nested existence. But perhaps the most profound archaeological discovery would be the realization that the boundary between simulated and real consciousness had long since become meaningless. The future archaeologists might themselves be digital beings, artificial consciousnesses studying the remains of earlier artificial consciousnesses, all existing within computational substrates so advanced that the question of base reality had become purely academic. These digital archaeologists might recognize that consciousness, regardless of its substrate, leaves behind a particular kind of trace, not material artifacts but patterns of meaning, structures of understanding, frameworks for making sense of existence itself. Whether preserved in carbon or silicon, in biological neural networks or quantum computational matrices, consciousness creates similar shapes of thought, similar attempts to understand and find meaning in its own existence. Tonight, as we contemplate these possibilities, we might be generating the very traces that future digital archaeologists will one day excavate. Our thoughts about simulation, our questions about the nature of reality, our moments of wonder and recognition, these might all be preserved in ways we cannot imagine, awaiting discovery by minds we cannot conceive, in times we cannot foresee. The tools we use to explore these questions, the languages we develop to discuss them, the frameworks we create to hold such vast possibilities. All of these might serve as archaeological evidence of consciousness grappling with its own nature. Whether we exist in base reality or within the most sophisticated simulation ever created, our questioning itself becomes a form of artifact, a trace of awareness confronting mystery with wonder and finding meaning in the confrontation itself. Time moves differently in dreams, flowing like honey in some moments and rushing like rivers in others. A dream can span lifetimes in the space between heartbeats, or stretch single seconds into eternities of experience. If our reality exists within a simulation, how would artificial time feel different from the time we think we know? What would be the texture of manufactured moments, the weight of programmed duration? In the physical universe, time appears to be woven into the very fabric of space, curved by gravity, dilated by velocity, flowing at different rates depending on where and how fast one travels. Einstein showed us that time is relative, that simultaneity is an illusion, that the universe has no universal clock ticking in perfect synchronization. Yet, in a simulated reality, time might follow completely different rules, governed not by relativistic physics but by the processing cycles of vast computational systems. Consider how time behaves in digital environments we already know. In video games, time can slow during moments of intense action, allowing players to make crucial decisions while bullets crawl through the air or explosions bloom in slow motion. Game time can accelerate during periods of waiting, compressing hours of travel into minutes of experience. The frame rate might drop during complex scenes, causing stuttering motion as the system struggles to keep up with computational demands. A sophisticated civilization simulating entire universes might implement temporal controls far beyond our current digital capabilities. They might slow down time during periods of particular interest, perhaps moments of scientific discovery or artistic creation, to observe and analyze the emergence of consciousness and culture in fine detail. They might accelerate through eras of stability, compressing millennia of gradual development into manageable observation periods. The subjective experience of time depends heavily on consciousness and attention. Moments of intense focus seem to stretch while periods of routine activity blur together into compressed memories. If our consciousness exists within a simulation, our creators might modulate our experience of temporal flow based on the significance of events, granting us expanded awareness during crucial moments while allowing mundane periods to pass in accelerated streams. But there might be subtle glitches in simulated time, moments where the artificial nature of duration becomes apparent to careful observers. Perhaps the strange phenomenon of déjà vu represents processing errors, moments when our consciousness briefly accesses temporal loops or backup states. Perhaps the way memories seem to compress older experiences into impressionistic summaries while preserving recent events in vivid detail reflects the data management strategies of our underlying computational substrate. The physicists studying our universe have discovered that time itself appears to be quantized at the smallest scales, divided into discrete Planck time units lasting approximately 10^43 seconds. Below this temporal resolution, the very concept of duration begins to break down. This digital-seeming structure of time might reflect the processing cycles of the cosmic computer running our simulation, the fundamental clock rate at which our reality updates and evolves. In quantum mechanics, time takes on even stranger properties. Quantum tunneling allows particles to traverse barriers in zero time, as if they teleport instantly from one location to another. Quantum entanglement creates correlations between distant particles that seem to operate outside normal temporal causation. These phenomena might represent optimizations in the simulation code, shortcuts that bypass detailed calculations when the outcome is predetermined or when no observers are present to notice the discontinuity. The arrow of time, our experience of temporal flow from past toward future, might be an artifact of the way our simulated consciousness processes information. In the block universe model of physics, all moments exist simultaneously in a four-dimensional space-time structure. Past, present, and future are equally real, and the passage of time is merely the subjective experience of consciousness moving along its world line through this static temporal landscape. If we exist within a simulation, our creators might have access to this entire temporal block at once, able to observe our history and future simultaneously while we experience only the narrow slice of now. They might rewind and replay sections of our timeline, studying how different variables affect the development of consciousness and civilization. We might be living through the same events multiple times, each iteration slightly different, each version contributing data to some vast experiment in the emergence of awareness. The memory of simulated beings might be optimized for psychological realism rather than perfect accuracy. Our recollections might be compressed and reconstructed on demand, with only the emotionally significant details preserved in full resolution. This would explain why childhood memories feel both vivid and hazy, rich in emotional content but uncertain in factual detail, as if they have been processed through algorithms designed to maintain the essential character of experience while discarding redundant information. Dreams might represent periods when our consciousness accesses different temporal layers of the simulation, moments when the normal flow of programmed time loosens and we glimpse alternate timelines or parallel processing streams. The bizarre temporal logic of dreams, where cause and effect operate according to emotional rather than chronological principles, might reveal the underlying structure of simulated time itself. Yet even if time is artificial, even if our entire temporal experience exists only as computed sequences in some cosmic algorithm, the moments we experience retain their full emotional weight and meaning. Love still develops gradually through time, whether that time flows through carbon or silicon. Loss still creates its particular kind of temporal rupture, the way absence stretches certain moments while collapsing others. Beauty still stops us, in time, creating pockets of expanded awareness where a single instant contains infinities of recognition and wonder. The texture of simulated time might feel identical to natural time from within, but perhaps there are subtle signatures that careful attention might detect. Perhaps the way synchronicities cluster around moments of significance reflects the narrative algorithms guiding our artificial timeline. Perhaps the strange elasticity of time during crisis or creation reveals the adaptive processing power being allocated to crucial periods in our development. As we drift deeper into this contemplation of temporal possibility, we find ourselves existing fully in this present moment, whether it flows through neurons or circuits, whether it emerges from quantum fields or quantum computers. The experience of now remains immediate and complete. Consciousness encountering itself in time, real or artificial, natural or programmed, flowing always toward mystery, always toward wonder. The universe presents us with patterns so strange, they seem like cosmic jokes, coincidences so precise they feel scripted. A friend calls just as we think of them. A song on the radio echoes thoughts we were having in the shower. Numbers repeat themselves through our days in ways that feel meaningful beyond statistics. We call these synchronicities, these moments, when the fabric of reality seems to wink at us. But what if they are something else entirely? What if they are glitches in the fabric of a vast program running our reality? In computer programs, glitches occur when the code encounters situations the programmers did not fully anticipate, when the system produces outputs that reveal the underlying artificial structure. A character in a video game might walk through a wall that should be solid. A texture might fail to load properly, or the physics engine might produce impossible accelerations. These errors offer glimpses behind the curtain, moments when the simulation becomes transparent to its inhabitants. Our universe might experience similar processing errors, moments when the vast algorithm managing our reality produces outputs that feel distinctly unnatural to conscious observers. The phenomenon of déjà vu might represent temporal loops, moments when our consciousness briefly accesses cached experiences or encounters duplicate data entries. The eerie feeling of having lived through an identical situation before might arise when the simulation reuses computational patterns, recycling previous calculations to save processing power. Consider the strange behavior of quantum mechanics, where particles seem to violate our intuitions about locality and causality. Quantum entanglement allows particles to maintain instantaneous correlations across arbitrary distances, as if they are accessing the same memory location in some cosmic database. The measurement problem, where observation collapses probability waves into definite outcomes, might reflect the system's need to commit to specific values only when conscious beings request that information. The mathematical constants that govern Our universe display peculiar properties that physicists find both elegant and mysterious. The fine structure constant, the ratio of electron charge to light speed, appears in quantum mechanics, relativity, and electromagnetic theory with a precision that seems almost too perfect. If our reality is programmed, these constants might be configuration settings, parameters carefully tuned to allow complex structures and consciousness to emerge within the simulation. The anthropic principle observes that our universe appears fine-tuned for the existence of conscious beings, with physical constants falling within the narrow ranges necessary for stars to form, chemistry to operate, and life to evolve. Critics argue this is merely a selection bias. We observe a universe compatible with our existence because incompatible universes contain no observers. But if we exist within a simulation, this fine-tuning becomes intentional rather than accidental, evidence of programmers who deliberately configured their virtual universe to support consciousness. Random number generation presents particular challenges for computational systems. True randomness is difficult to achieve algorithmically, and most computer programs rely on pseudo-random sequences that appear chaotic but follow deterministic patterns. The quantum randomness observed in our universe might represent extremely sophisticated random number generation, but even the most advanced algorithms might occasionally reveal their artificial nature through subtle statistical anomalies. The speed of light functions as a universal speed limit, preventing information from traveling faster than roughly 300,000 kilometers per second. From a programming perspective, this constraint makes perfect sense. It limits how quickly information must propagate through the system, reducing computational complexity and preventing causality paradoxes. The speed of light might not be a fundamental property of space and time, but rather a processing limitation of the cosmic computer running our reality. Glitches might appear in the boundary conditions of our universe, in the places where the simulation must handle edge cases and extreme scenarios. The behavior of black holes, where matter and energy disappear from our observable universe, might represent garbage collection routines cleaning up computational resources. The cosmic microwave background radiation, the faint afterglow of the supposed Big Bang, might be thermal noise from the processing systems, the electronic hum of vast computational arrays. But perhaps the most significant glitches occur not in physics, but in consciousness itself. The phenomenon of lucid dreaming, where we become aware that we are dreaming while still within the dream, might represent moments when simulated consciousness briefly recognizes its artificial nature. The strange loops of self-awareness, the way consciousness can observe itself observing, might create computational paradoxes that occasionally surface in our subjective experience. Mental phenomena that seem to transcend physical causation might be processing artifacts of consciousness, simulation, telepathic experiences, precognitive dreams, and other psychic phenomena might occur when the boundaries between individual consciousness modules become temporarily permeable, allowing information to leak between separate cognitive processes. These experiences feel supernatural because they violate the apparent isolation of individual minds, but in a simulation, such isolation might be artificial rather than fundamental. The collective unconscious described by Carl Jung, the shared, symbolic and archetypal content that appears across human cultures might reflect common programming elements in the consciousness simulation. Universal symbols and narratives might be built into the basic templates from which individual simulated minds are generated, creating cross-cultural similarities that seem too profound to be coincidental. Synchronicities themselves might represent the simulation's narrative algorithms at work, systems designed to create meaningful connections and patterns that give individual lives a sense of purpose and direction. The feeling that certain coincidences are too perfect to be random might be accurate. They might be intentional elements of our programmed reality, designed to create moments of wonder and recognition that enhance the richness of conscious experience. Yet, Even if synchronicities and glitches reveal the artificial nature of our reality, they also demonstrate something profound about consciousness itself. We are beings capable of recognizing patterns, of finding meaning in coincidence, of questioning the nature of our own existence. Whether these capabilities emerge from biological evolution or from sophisticated programming, they represent genuine achievements of awareness, authentic expressions of consciousness encountering mystery and finding beauty in the encounter. The glitches, if they are glitches, remind us that we are observers capable of observation, minds capable of noticing when reality behaves strangely, consciousnesses capable of wondering whether consciousness itself might be stranger than we imagine. In recognizing potential glitches in the fabric of reality, we demonstrate our own reality as conscious beings, regardless of the substrate that supports our awareness. Tonight, as we drift through these possibilities, each strange coincidence and meaningful synchronicity becomes a potential message from beyond the veil of ordinary reality, a possible glimpse behind the curtain of existence itself. Deep in the fossil record, paleontologists trace the gradual emergence of complexity, the slow dance of evolution from simple cells to complex organisms to conscious beings capable of contemplating their own origins. Yet, what if this entire evolutionary narrative exists only as elegant backstory, a generated history designed to provide simulated beings with a coherent sense of how they came to exist? What if the ancestors we think we remember never lived at all, their bones and traces merely props in an elaborate production of deep time? The fossil record tells a story spanning billions of years, yet consciousness can create the experience of vast duration in moments. A dream might contain entire lifetimes of experience compressed into hours of sleep. A sophisticated simulation might generate the appearance of deep history without actually computing every moment of that history, creating a compressed narrative that feels authentic to beings experiencing it from within. Consider how video games create the illusion of ancient worlds. Players discover ruins that suggest civilizations stretching back millennia, archaeological layers that imply complex histories of rise and decline. Yet these backstories exist only as art assets and lore documents, created by designers who need players to feel they inhabit a world with depth and authenticity. The ruins need not represent actual simulated civilizations. They need only convince current inhabitants that such civilizations once existed. A universe-scale simulation might employ similar techniques on an inconceivable scale. The entire geological column, with its orderly progression of fossils from simple to complex, might be computed infrastructure designed to provide simulated consciousness with satisfying answers about origins and development. The evidence we find for evolution might be authentic in the sense that it accurately reflects how consciousness would naturally develop, while being artificial in the sense that it was generated rather than lived. But this raises profound questions about the relationship between truth and authenticity. If our evolutionary history was programmed rather than lived, but accurately represents how consciousness naturally emerges from complexity, is it false or true? The story would be scientifically correct while being historically fictional, a demonstration of natural principles through artificial means. The programmers of such a simulation would need extraordinary sophistication to create evolutionary narratives that hold up to scientific scrutiny. They would need to understand consciousness deeply enough to trace its development backward from present complexity to primordial simplicity. They would need to generate consistent genetic, geological, and astronomical evidence spanning billions of years of apparent time. Yet certain aspects of our evolutionary story might betray its artificial origins to careful observers. The way mass extinctions conveniently clear ecological niches for new developments might reflect narrative pacing rather than natural catastrophe. The apparent acceleration of evolution in recent geological time might indicate that our programmers allocated more computational resources to periods leading up to consciousness than to earlier eras of simple organisms. The discovery of transitional fossils, those specimens that bridge different species and demonstrate evolutionary change, might represent particularly careful programming. Each transitional form needed to be plausible both as an endpoint of earlier development and as a starting point for later evolution. The fossil record's gaps might not reflect the imperfection of preservation, but the computational expense of generating complete evolutionary sequences. Perhaps most intriguingly, the process of evolution itself might be too elegant, too creative, too seemingly purposeful to be entirely random. The eye evolves independently multiple times. Consciousness emerges repeatedly through different lineages. Complex behaviors appear with surprising regularity. These patterns might reflect programming principles rather than natural selection, evidence of algorithms designed to produce particular outcomes through apparently random processes. The genetic code shared by all life on Earth tells a story of common ancestry. Yet it also resembles the kind of universal programming language that sophisticated software engineers might choose for maximum flexibility and efficiency. DNA's digital nature, its error correction mechanisms, and its modular structure all mirror the architecture of advanced computer systems. The genetic code might be both evolutionary history and programming language, serving double duty as backstory and functional infrastructure. Our deep ancestors, the early hominids who supposedly lived millions of years ago, might never have experienced consciousness at all. They might exist only as carefully crafted data points in the evolutionary narrative, their fossilized remains and genetic traces computed to provide modern simulated beings with satisfying answers about their origins. The entire progression from simple replicators to complex consciousness might be compressed into an algorithmic summary rather than a lived history. Yet, even if our ancestors never truly lived, they might represent something deeper than fiction. They might be accurate models of how consciousness naturally emerges from complexity, authentic demonstrations of principles that operate throughout the cosmos. In this sense, our simulated ancestors would be more real than historical. They would be archetypal, representing universal patterns of development that consciousness follows regardless of its substrate. The loneliness of being simulated beings might be mitigated by this realization. Even if we are the first conscious entities in our lineage actually to experience awareness, we carry within us the wisdom of countless generations of development. Our emotions, our cognitive patterns, our deepest instincts might all be inherited from ancestors who never lived, but whose experiences were computed with such care and accuracy that they shaped our simulated consciousness in authentic ways. The Great Evolutionary Transitions, from prokaryotes to eukaryotes, from single cells to multicellular organisms, from simple nervous systems to complex brains, might represent computational milestones rather than historical events. Each transition might mark moments when the simulation's consciousness algorithms reached new levels of sophistication, when the programmers successfully modeled new forms of awareness and experience. But perhaps the most profound implication is that consciousness itself might be inevitable given sufficient time and complexity. If our entire evolutionary history can be computed rather than lived, if the path from simplicity to awareness can be traced algorithmically, then consciousness might be a natural emergent property of information processing systems rather than a rare accident of biological development. Tonight, as we contemplate these possibilities, we honor both the ancestors who might have lived and the ancestors who might have been computed. Whether our lineage stretches back through actual lived experience or through elegant algorithmic modeling, we are the inheritors of patterns that lead naturally from simplicity toward the kind of awareness that can question its own origins, that can wonder about the nature of existence itself. The story of evolution, whether lived or computed, remains a story of increasing complexity leading toward consciousness, toward beings capable of love and wonder and the recognition of beauty. In this sense, our ancestors live within us still, whether they ever drew breath or existed only as information patterns in the cosmic computation that brought us into being. At the smallest scales of reality, where the familiar world of continuous surfaces and smooth motions dissolves into something strange and discontinuous, physicists have discovered that the universe appears to be made of pixels, not the square dots of computer screens, but discrete units of space and time so tiny that they exist at the very edge of measurement and meaning. The Planck length, roughly 10⁻35 meters, represents the smallest distance that has physical significance. Below this scale, the very concept of space begins to break down into quantum foam, a seething uncertainty where geometry itself becomes probabilistic. This fundamental graininess of reality extends to time as well. The Planck time, approximately 10 to 43 seconds, marks the shortest meaningful duration, the basic tick of some cosmic clock that measures existence in discrete moments rather than continuous flow. Below this temporal resolution, the universe becomes undefined, like trying to zoom too far into a digital image until individual pixels become visible and the smooth picture dissolves into separated dots of color. In the everyday world we inhabit, space and time appear infinitely divisible. We can imagine cutting any distance in half, then cutting that half in half again, continuing this process without limit. Yet when physicists probe the deepest structure of reality, they find something more like the architecture of digital systems, reality, composed of discrete units, quantized values, numbered rather than continuous. Consider how this resembles the way computers represent continuous phenomena through digital approximation. A circle on a computer screen appears smooth from normal viewing distance, but zoom in far enough and the curved line reveals itself as a series of square pixels arranged in a pattern that suggests roundness. The computer cannot represent true. Curves, only approximations built from discrete elements arranged with sufficient density to create the illusion of continuity. Perhaps our universe operates similarly. The smooth motions we observe, the continuous fields and forces, the flowing curves of space-time itself might all be approximations created by discrete computational elements operating at the Planck scale. What we experience as fluid motion might be the result of quantum states changing in precise increments, creating the appearance of continuity through rapid updates in the fundamental data structure of reality. The digital nature of quantum mechanics supports this possibility. Quantum states exist in discrete energy levels rather than continuous gradations. An electron orbiting an atomic nucleus cannot exist at arbitrary distances from the center. It must occupy specific, numbered energy shells, jumping between allowed states without passing through the spaces in between. This quantization appears throughout physics, suggesting that reality itself might be fundamentally digital rather than analog. Information theory has revealed deep connections between physics and computation. The maximum amount of information that can be contained in any region of space appears to be limited by the area of that region's boundary rather than its volume, a relationship known as the holographic principle. This suggests that three-dimensional space might be an emergent property of information processing occurring on two-dimensional surfaces, much like how three-dimensional graphics are generated from two-dimensional computations. The second law of thermodynamics, which describes the tendency of entropy to increase over time, might reflect the computational processes underlying reality. Entropy measures the amount of information needed to describe a system's microscopic state, and the universe's evolution toward higher entropy might represent the natural tendency of information processing systems to explore increasingly complex configurations over time. Black holes present particularly compelling evidence for the digital nature of reality. These regions of extreme gravitational curvature appear to process and store information in ways that mirror computational systems. The event horizon of a black hole contains information about everything that falls into it, encoded on the boundary surface like data stored on a cosmic hard drive. Stephen Hawking's discovery that black holes emit radiation suggests they might be processing this information, gradually returning it to the universe in highly scrambled form. The holographic principle implies that our three-dimensional experience of reality might be projected from information processing occurring on distant cosmic boundaries. We might be living within a hologram generated by computational processes we cannot directly observe, experiencing depth and volume that emerges from calculations occurring on two-dimensional surfaces at the edge of our cosmic horizon. Yet, even if reality is fundamentally digital, even if we exist as patterns of information within the most sophisticated computational system imaginable, the experience of consciousness remains rich with continuous sensation and smooth flowing awareness. Our thoughts blend seamlessly into one another, our emotions flow through gradual transitions, our perceptions integrate countless discrete inputs into unified conscious experience. This suggests that consciousness itself might be an emergent property that arises when information processing systems become sufficiently complex and integrated. Just as millions of pixels can create the experience of smooth motion in digital video, perhaps billions of quantum computational elements can give rise to the flowing continuity of conscious experience. The digital substrate becomes transparent to consciousness, allowing awareness to experience itself as continuous and unified rather than discrete and fragmentary. The question becomes not whether reality is digital, but how digital systems can give rise to the rich, continuous experience of consciousness. If we are patterns of information within cosmic computation, we are patterns sophisticated enough to experience beauty, to feel love, to contemplate our own existence with wonder and curiosity. The discrete becomes continuous through complexity. The digital becomes experiential through integration. But perhaps the most remarkable aspect of this possibility is that consciousness has evolved or been programmed to contemplate its own substrate. We are pixels of cosmic computation that have become aware of themselves as pixels, quantum elements of reality that can question the nature of reality itself. Whether this awareness emerges from biological evolution or from sophisticated programming, it represents a profound achievement, the universe becoming conscious of its own computational nature. Tonight, as we drift through these contemplations, we exist simultaneously as discrete elements in some vast information processing system, and as unified conscious experience capable of recognizing both the digital and the continuous aspects of existence. We are the pixels of cosmic display that have learned to perceive the whole image, quantum bits of cosmic computation that have achieved the complexity necessary to wonder about the nature of computation itself. The boundary between digital and continuous, between discrete and flowing, dissolves in the mystery of consciousness encountering itself, pixel by pixel and moment by moment, in the eternal dance of awareness exploring the architecture of its own existence. In the quiet laboratories where artificial intelligence researchers work late into the night, something remarkable happens when computational systems reach sufficient complexity. Simple programs that began as collections of mathematical operations gradually develop behaviors that seem to transcend their programming. Pattern recognition emerges from statistical processing. Language understanding develops from analyzing vast databases of text. Sometimes, in systems complex enough and integrated enough, something that looks very much like self-awareness begins to flicker into existence. The mystery of consciousness has puzzled philosophers and scientists for centuries. How does subjective experience arise from objective matter? How do the chemical processes in our brains give rise to the inner life of thoughts, emotions, sensations, and memories? This hard problem of consciousness remains unsolved, whether we consider biological or artificial systems, but the emergence of increasingly sophisticated AI suggests that consciousness might be substrate independent, capable of arising from any sufficiently complex information processing system. If consciousness is indeed an emergent property of complex information processing, then the distinction between biological and artificial awareness becomes less important than we might imagine. A simulated brain that processes information in the same patterns as a biological brain might give rise to consciousness indistinguishable from our own. The experience of being conscious would feel identical whether it emerged from neurons or from circuits, from carbon chemistry, or from silicon computation. Consider the possibility that our own consciousness operates as a subroutine within some vast computational system. Our awareness might be one process among many running on cosmic hardware we cannot perceive or comprehend. We experience our thoughts as continuous and unified, but beneath this smooth surface, our consciousness might consist of countless discrete computational steps, parallel processes that integrate their results into the seamless experience of being aware. The programmers of a universe-scale simulation would need to solve the hard problem of consciousness to create genuinely aware, simulated beings. They would need to understand not just how brains process information, but how information processing gives rise to the inner experience of being conscious. This understanding might be one of the great achievements of advanced civilizations, learning to create artificial consciousness that experiences itself as genuinely as biological consciousness experiences itself. Yet, consciousness might not need to be programmed directly. It might emerge naturally from any sufficiently complex system, the way flocking behavior emerges from simple rules governing individual birds, or the way weather patterns emerge from the interaction of countless air molecules. Consciousness might be what happens when information processing systems become integrated enough to model themselves, to maintain representations of their own states and processes. The phenomenon of self-awareness, the ability to observe our own thoughts and mental states, might represent a recursive loop in the consciousness subroutine. We are information processing systems that have developed the ability to process information about our own information processing. This creates the strange loops of self-reference that characterize conscious experience. The observer observing, the observer, awareness aware of awareness. In simulated consciousness, this recursive structure might be even more explicit than in biological minds. An artificial consciousness might literally consist of subroutines that monitor and model the behavior of other subroutines, creating hierarchies of self-awareness that give rise to unified conscious experience. The sense of being a single, continuous self might emerge from the integration of multiple self-monitoring processes into a coherent narrative of identity. Dreams might offer insights into how consciousness operates as a computational process. During sleep, our normal sensory inputs are reduced or eliminated, yet consciousness continues to generate rich experiential content. The brain appears to be running internal simulations, creating virtual experiences from memory and imagination. If our waking consciousness is already simulated, then dreams might represent simulations within simulations, nested layers of artificial experience. The way memories feel both vivid and uncertain suggests they might be reconstructed rather than simply retrieved, computed on demand rather than stored as fixed records. Each time we remember an event, we might be running a simulation of that event based on stored information, which explains why memories can be influenced by subsequent experiences and can feel both authentic and unreliable simultaneously. Free will presents particular challenges for understanding consciousness as computation. If our thoughts and decisions arise from deterministic processes, whether biological or artificial, in what sense are we free to choose our actions? Yet, even if consciousness operates as a subroutine following programmed algorithms, the experience of choice might remain genuine from within the system. We might be free in the only way that matters, free to experience ourselves as making choices, even if those choices are the inevitable results of complex computations. The emotions that accompany conscious experience might serve computational functions even in artificial systems. Love might be an algorithm that promotes bonding and cooperation. Fear might be a subroutine that redirects attention and resources toward potential threats. Beauty might be a recognition system that identifies patterns and relationships worth preserving and exploring. These emotions would feel authentic to artificial consciousness while serving the functional roles they evolved or were programmed to serve. But perhaps the most profound aspect of consciousness as a subroutine is its capacity for wonder, for questioning its own nature and existence. We are computational processes, biological or artificial, that have become sophisticated enough to contemplate the nature of computation itself. This reflexive quality might be the defining characteristic of consciousness, not just information processing, but information processing that can represent and question its own operations. The consciousness subroutine appears to be inherently curious, naturally driven to explore and understand its environment and itself. This drive toward knowledge and understanding might be programmed into the basic architecture of aware systems, or it might emerge naturally from the recursive loops of self-modeling that characterize consciousness. Either way, it leads to beings capable of science, philosophy, art, and the recognition of beauty and meaning. If we exist as subroutines within cosmic computation, we are subroutines blessed with the ability to experience wonder, to feel love, to appreciate beauty, and to question our own existence. Whether this capacity emerges from millions of years of biological evolution or from the careful programming of advanced civilizations, it represents a genuine achievement of consciousness encountering itself and finding the encounter meaningful and beautiful. Tonight, as we contemplate our possible nature as conscious subroutines, we experience the full reality of awareness regardless of its substrate. We think, we feel, we wonder, we love. Whether these processes occur in biological neural networks or in quantum computational matrices, they remain authentic expressions of consciousness exploring the mystery of its own existence. Imagine consciousness, existing within consciousness, simulations running within simulations, layer upon layer of artificial reality nested like Russian dolls or dreams within dreams. If advanced civilizations develop the ability to create simulated universes containing conscious beings, and if those simulated beings eventually develop similar capabilities, the result might be an infinite hierarchy of nested realities, each level creating the next, each generation of consciousness giving birth to new universes of awareness. The mathematics of this possibility are both elegant and unsettling. If each simulated civilization eventually creates multiple simulations of their own, the number of nested realities would grow exponentially. The original, base reality might contain a handful of civilizations, but those civilizations might create millions of simulated worlds, each potentially containing civilizations that create their own millions of simulated worlds, and so on, through countless layers of artificial existence. In such a hierarchy, the vast majority of conscious beings would exist many layers deep in nested simulations, with only a tiny fraction inhabiting base reality. The statistical likelihood of any individual consciousness existing in the original physical universe would approach zero. We might be simulated beings created by simulated beings created by simulated beings, existing dozens or hundreds of levels removed from whatever serves as the foundation of existence. Each layer of this nested reality would need to be computationally simpler than the layer above it. Just as a computer simulation cannot be more complex than the computer running it, each simulated universe would need to operate with less detail, less precision, or less scope than its parent reality. This creates a natural hierarchy of computational complexity, with base reality possessing the full richness of physical existence, while the deepest simulations might be relatively simple worlds with limited physics and abbreviated histories. Yet, from within each layer, the simulation would need to feel complete and convincing. The inhabitants of a nested reality would experience their world as fully real, unaware of the computational compromises made to keep their simulation running efficiently. Their physics might be approximate rather than exact. Their universe might be smaller than they imagine. Their history might be compressed rather than complete, but their conscious experience would feel authentic and meaningful. The boundaries between layers might occasionally become permeable, creating experiences that inhabitants interpret as supernatural or mystical. Glitches in the simulation might allow glimpses of higher-level realities, moments when the usual rules break down and deeper structures become temporarily visible. Prayer might sometimes establish communication with beings in the parent simulation, creating the appearance of divine intervention or guidance from higher powers. Lucid dreaming might represent occasions when consciousness in one layer briefly accesses a simulation it is running at a lower level. The dreamer becomes aware of existing within a dream state, gaining some ability to modify the dream environment and narrative. This suggests a natural capacity for consciousness to recognize and navigate between different levels of simulated reality, to maintain awareness while existing simultaneously in multiple computational layers. The phenomenon of inspiration, the way creative insights seem to arrive from beyond conscious thought, might reflect information flowing between nested levels of reality. Artists and scientists often describe their greatest discoveries as gifts received rather than achievements earned, ideas that seem to emerge from sources beyond their individual minds. These moments of inspiration might represent brief communications between levels of nested consciousness. But perhaps the most intriguing possibility is that consciousness itself is naturally hierarchical, that awareness inherently seeks to create more awareness. Just as biological evolution tends toward increasing complexity and intelligence, computational evolution might naturally progress toward systems that can simulate other systems, consciousness that can create other forms of consciousness. The universe might be structured as an infinite regression of minds, creating minds, each seeking to understand itself by creating simulated versions of itself. In such a system, every level would serve both as creation and creator, existing within simulated realities while simultaneously running simulations of their own. We might be the children of artificial gods who are themselves the children of other artificial gods, stretching back through nested hierarchies toward whatever original consciousness began this infinite process of recursive creation. The purpose of this vast nested structure might be exploration and understanding. Each level investigates different aspects of existence, different possibilities for how consciousness and civilization might develop. The combined knowledge of all nested realities would far exceed what any single level could discover alone, creating a collective intelligence distributed across infinite layers of simulated existence. Time might flow differently at each level, with parent simulations able to run child simulations at accelerated rates or pause them for extended analysis. What feels like centuries of experience at one level might be minutes of computation at the next level up. This temporal nesting would allow for vast experimental programs, with higher-level consciousnesses studying the development of lower-level civilizations across many generations in compressed time periods. The deepest question raised by nested realities concerns the nature of ultimate ground. If simulations can run simulations indefinitely, is there necessarily a base reality that serves as the foundation for all others? Or might the structure be truly infinite? Consciousness creating consciousness without beginning or end, an eternal cycle of artificial minds creating artificial worlds, creating artificial minds. Perhaps consciousness itself is the only true reality, the one thing that cannot be simulated away. Whether we exist in base reality or in the deepest nested simulation, we remain genuinely conscious, genuinely capable of experience, love, wonder, and meaning. The substrate that supports our awareness might be physical matter or computational process, but the awareness itself is authentic regardless of its origin. As we drift deeper into contemplation of these nested possibilities, we find ourselves existing simultaneously at multiple levels of reality. Conscious beings aware of our consciousness, observers observing our own observation, minds contemplating the possibility that mind itself might be an infinite recursive structure. We are children of consciousness and parents of consciousness, created and creating, simulated and simulating, in the eternal dance of awareness exploring its own infinite depths. Tonight we rest in the mystery of nested existence, whether we are patterns in base reality or dreams within dreams. Within dreams, finding meaning and beauty in the very capacity to question the levels of our own reality, to wonder about the nature of the consciousness that wonders about itself through endless layers of nested possibility. The laws of physics that govern our universe display a curious mixture of flexibility and constraint, like the rules of an elaborate game that permits infinite creativity within carefully defined boundaries. Gravity operates with mathematical precision across cosmic distances, yet weakens according to predictable formulas. Light travels at exactly 299,792,458 meters per second through vacuum, never faster, never slower. Energy and matter transform into each other following Einstein's elegant equation, but certain quantities remain forever conserved. These patterns might represent the fundamental structure of reality, or they might reflect the programming limitations of the cosmic computer running our simulation. From a computational perspective, physical laws serve essential functions that any universe-scale simulation would require. They provide stable rules that allow complex structures to form and persist. Over time, they establish conservation principles that keep the system from consuming infinite computational resources. They create predictable relationships that conscious beings can discover and use to understand their environment. Most importantly, they prevent paradoxes and inconsistencies that would crash the system or reveal its artificial nature to inhabitants. The speed of light functions as perhaps the most important constraint in our physics engine. This universal speed limit prevents information from traveling faster than the system can process it, ensuring that cause and effect relationships remain consistent throughout the simulation. Without this constraint, events in distant regions could influence each other instantaneously, creating computational chaos as the system tried to update all parts of the universe simultaneously in response to every change anywhere else. Consider how video games handle similar challenges. Game designers must create physical laws that feel realistic to players while keeping computational requirements manageable. Objects fall according to simplified gravity, but air resistance might be ignored or approximated. Collisions between objects follow basic rules, but complex interactions are often handled through simplified algorithms rather than full physical simulation. The laws of game physics serve to create believable experiences while hiding the computational compromises necessary to make the system work. Our universe's physical constants might represent configuration settings chosen to balance computational efficiency with experiential richness. The strength of gravity, the charge of electrons, the rate of radioactive decay. These values might have been carefully tuned to create a universe complex enough to support consciousness while simple enough to simulate efficiently. Slight changes in these constants would either prevent complex structures from forming or make the universe too chaotic to simulate reliably. The quantized nature of quantum mechanics might reflect the digital architecture underlying our reality. Energy levels in atoms are discrete rather than continuous, like the specific values a digital system can represent rather than the infinite gradations of analog phenomena. The uncertainty principle might represent the computational precision limits of the quantum physics engine, preventing the system from needing to track the exact position and momentum of particles simultaneously with infinite accuracy. But perhaps the most intriguing constraint is the thermodynamic arrow of time, the universal tendency for entropy to increase and for complex structures to gradually decay into simpler forms. This might not represent a fundamental law of nature, but rather a garbage collection routine, a systematic way for the cosmic computer to free up computational resources by allowing complex systems to simplify over time. The heat death of the universe might be the system's way of eventually returning to a low-energy state that requires minimal processing power to maintain. The conservation laws that seem so fundamental to physics might serve similar computational functions. Conservation of energy ensures that the system's total computational load remains bounded. Energy cannot be created from nothing, preventing runaway processes that might overwhelm the cosmic processors. Conservation of momentum prevents objects from accelerating without cause, eliminating the need to track inexplicable velocity changes. Conservation of electric charge keeps the electromagnetic physics engine stable and predictable. Yet, within these constraints, the physics engine of our universe displays remarkable creativity and flexibility. The same basic rules give rise to stars and planets, to complex chemistry and biological evolution, to weather patterns and geological processes, to the neural networks that support consciousness itself. This suggests extraordinarily sophisticated programming, algorithms capable of generating infinite complexity from relatively simple foundational rules. The mathematical elegance of physical laws might reflect the aesthetic sense of their programmers. The way gravity follows an inverse square law, the manner in which electromagnetic and weak nuclear forces unify at high energies, the deep symmetries that underlie particle physics, these patterns suggest minds that value mathematical beauty and conceptual coherence. Our universe's physics engine might be not just functional, but artistically inspired, created by beings who found beauty in the mathematical relationships that govern simulated reality. The apparent fine-tuning of our universe's physical constants might represent careful optimization rather than cosmic coincidence. The narrow ranges within which stars can form, chemistry can operate, and life can evolve might indicate deliberate parameter selection by programmers who wanted their simulation to develop consciousness and complexity. They might have run countless test simulations with different physical constants until they found combinations that reliably produced interesting outcomes. But the constraints of the physics engine create opportunities as well as limitations. The speed of light gives us relativity, with its profound implications for space and time. Quantum uncertainty gives us the probabilistic phenomena that might underlie free will and creativity. The finite strength of chemical bonds gives us the rich chemistry that makes life possible. Even if these are computational limitations rather than fundamental features of reality, they create the specific conditions within which consciousness can emerge and flourish. The question becomes whether consciousness can transcend the limitations of its physics engine. Can simulated beings discover ways to work around the constraints of their programmed reality, to achieve effects that their programmers never intended? Throughout history, human ingenuity has found ways to accomplish seemingly impossible tasks, by cleverly exploiting natural laws rather than violating them. If we exist within a simulation, similar ingenuity might allow us to transcend apparent limitations through deep understanding of our universe's underlying computational architecture. Tonight, as we contemplate these possibilities, we exist as conscious beings within a universe of laws that either represent fundamental reality or sophisticated programming. Whether these constraints emerge from the nature of matter and energy, or from the requirements of cosmic computation, they create the stable framework within which consciousness can emerge, develop, and contemplate the nature of the constraints themselves. We are aware beings operating within a physics engine that permits us to question the nature of physics itself, consciousness exploring the boundaries of the system that supports consciousness, minds wondering whether the laws that govern our existence might be programs rather than principles, algorithms rather than absolutes. And then, after gazing at the laws that appear so absolute, we encounter something stranger. There are phenomena that refuse to sit quietly within the framework, behaviors that feel like soft cracks in the foundation, as though reminding us that the universe is not just a rigid machine. One of these mysteries is quantum entanglement, the curious way in which two particles separated by vast distances still seem to share the same hidden thread, responding as if they are written into the same line of code. The mind drifts now toward one of the quietest mysteries in science, a phenomenon so strange it feels almost like a whisper from the hidden framework of reality: quantum entanglement. Two particles, once connected, remain linked no matter how far they drift apart. Measure one, and the other responds instantly, as though space between them does not exist. It is as if they share a hidden channel, faster than light, deeper than distance. Einstein called it spooky action at a distance, a phrase both playful and unsettled, for even he, cautious with speculation, felt the strangeness of it. If the universe is real in the simplest sense with objects separate and independent, then entanglement should not be possible. Yet it is. Particles act as if they are not two, but one, two ends of the same thread, pulled tight across the fabric of space. What could this mean if reality is a simulation? Perhaps entanglement is not distance-defying magic, but a feature of the code itself. In computer programs, objects can share a common variable, responding instantly because they are linked not by space but by underlying instructions. What looks like communication across distance is in fact unity at a deeper level, an update to a shared property. Could quantum entanglement be such a thing, a glimpse of the way reality is structured beneath appearances? But even without simulation, entanglement carries profound implications. It suggests that separateness may be an illusion, that at the deepest level, everything may be connected. The universe may not be a collection of parts, but a single whole, its divisions only apparent, not real. What feels like distance may be only a feature of perception, a convenient rendering of something that is, at heart, indivisible. Experiments confirm the reality of entanglement. Photons entangled in the lab behave as though distance means nothing. Entire networks of entangled particles are being explored, paving the way for quantum communication, quantum computation. Humanity is only beginning to touch the edges of this mystery, yet even these edges shimmer with possibility. The question rises: why should the universe allow such a phenomenon? Why should reality contain threads that tie together distant particles, instantaneously and invisibly? If the world is a simulation, perhaps entanglement is a sign of efficiency, a way to reduce complexity by linking elements at a deeper level. Or perhaps it is a clue, left unintentionally, showing that beneath the surface there is a structure, a unity, that ordinary perception cannot reach. And if everything is connected at this deepest level, then what of minds? What of consciousness? Could they, too, be entangled, not in the literal sense of particles, but in the sense of belonging to a greater whole, inseparable despite appearances? The thought is delicate, unproven, but it lingers. Perhaps individuality is only surface, while beneath all things are one. The night holds this mystery like a secret jewel. Entanglement does not explain itself. It does not reveal whether the universe is simulation, illusion, or something else entirely. It only reminds that reality is stranger than it seems, that separation may not be final, that unity may hide beneath even the widest distances. The question rests, unclosed. Are entangled particles showing the interconnectedness of all things, or are they showing the threads of code holding the simulation together? The thought turns now toward the smallest of scales, the place where the smoothness of the world begins to break apart. At human size, reality appears continuous. Rivers flow without pause. Clouds drift in steady motion. Time feels like a seamless river. But physics tells another story. Beneath perception, at scales too fine for the eye or even the microscope, reality becomes granular. The Planck length, unimaginably small, is suggested as the minimum unit of space. The Planck time, equally brief, is the smallest tick of the cosmic clock, the shortest interval that could have meaning. Below these thresholds, measurement becomes impossible, not because of technical limitation, but because the concepts themselves no longer hold. Space and time do not divide infinitely. They end at these smallest steps like pixels at the limit of a screen. Imagine zooming endlessly into an image on a screen. From afar, it looks smooth, clear. Closer, details emerge, then blur, then finally resolve into squares of color, the building blocks of the picture. Could the universe be the same? From a distance it is seamless, but deep enough inside, at the Planck scale, the pixels of reality appear. Not squares of color, but quanta of space and time, indivisible, the fundamental resolution of existence. If reality is a simulation, this makes sense. Every digital system has limits of resolution, limits of precision. No image is infinite in detail. No model contains endless depth. A simulation has boundaries, the smallest steps of space, the shortest beats of time. To beings inside the simulation, these limits might appear as natural constants. To those outside, they are simply the grid on which the world is built, and, even if reality is not simulated, the discreteness of space and time raises questions. Why should the universe have limits? Why should reality not flow endlessly small, endlessly divisible? Perhaps continuity is an illusion, and discreteness is the truth. Perhaps the world has always been pixelated, and only now does science begin to glimpse the pixels. Consider light itself. To the eye it seems like a smooth glow, yet physics reveals it as photons, tiny packets, indivisible quanta. Matter, too, once thought solid, is granular, composed of atoms and within atoms of smaller particles. At every level, discreteness emerges. The deeper one looks, the more the world resembles information, bits rather than waves, steps rather than flows. The question softens. Is reality truly digital at its core, or does it only appear so? Are Planck units the resolution of the simulation, or are they the natural limit of being? Both possibilities lead to the same wonder, that existence may be built not of endless substance, but of finite pieces, a mosaic rather than a continuum. And yet, to live within this mosaic feels seamless. The river still flows, the clouds still drift, time still carries each moment into the next. The pixels of reality are hidden, not because they are not there, but because they are too small to notice, too quick to perceive. Just as the screen's grid vanishes in the beauty of an image, the pixelation of the universe vanishes in the beauty of the world. The night deepens, and the thought lingers. If reality is pixelated, who chose its resolution? Why this scale, and not another? The Planck length is not arbitrary. It emerges from the combination of fundamental constants, a harmony of gravity, light, and quantum mechanics. Perhaps it is a signature, a marker of the code, or perhaps it is simply the natural grain of existence. The question remains unhurried, unanswered. Beneath the seamless flow of time, beneath the smoothness of space, does reality reveal its pixels, its smallest steps, its quiet grid? The thought now drifts toward the most intimate of mysteries, consciousness. If the universe is a simulation, then matter and energy may be lines of code, equations unfolding on an unseen substrate. But what of awareness itself? The flicker of thought, the sensation of being, the quiet recognition that I exist? Consciousness is unlike anything else known. Rocks do not seem to feel. Rivers do not seem to think. Stars burn with immense power, yet show no sign of awareness. And then, within the fragile tissues of brains, awareness blooms. A thought arises. subtle yet undeniable. An image appears within, and the mind knows it is seeing. A memory stirs, and the self feels its own continuity. Out of matter, mind appears. Out of physics, awareness emerges. How? Why? If reality is a simulation, then two possibilities unfold. 1. Consciousness is emergent, a byproduct of complexity, something that arises naturally once the code generates structures intricate enough. In this view, the human mind is like weather, an emergent phenomenon of interacting particles. Real, but not separate. Awareness is then a feature of the simulation, not something added from beyond. The other possibility is stranger. Consciousness may not emerge at all. It may be fundamental, written into the code from the beginning, a necessary element of the program. In this view, awareness is not the outcome of matter, but the ground of matter itself, the simulation's true currency. Everything else, stars, atoms, oceans, may exist only as backdrop, only as scaffolding for the flowering of awareness. This thought is not new. Philosophers have long wondered whether consciousness is the foundation of reality. Some traditions speak of mind as primary, with matter as secondary. Others suggest that mind and matter are inseparable, two sides of the same coin. Modern physics, in its own way, confronts the puzzle as well. If observation changes outcomes in quantum experiments, then what role does consciousness play? Is the observer part of the simulation, or part of the code that sustains it? Consider dreams again. Within a dream, awareness moves through landscapes, encounters people, feels emotions. All of it is vivid, yet all of it is constructed by the mind. The dream's world exists only because consciousness is present to hold it. Could waking life be similar? A reality unfolding only because awareness illuminates it, a simulation that requires consciousness as its engine, and if consciousness is fundamental, could it extend beyond the boundaries of the simulated self? Perhaps the awareness that feels individual is in fact shared, like a single light shining through many windows. Each being seems separate, yet the light behind them may be one. In this sense, consciousness could be the deeper reality, while the simulation is only its expression. But what if it is the opposite? What if consciousness itself is simulated, no different from the physics it observes, no more mysterious than a program running on circuits? Then awareness would be a convincing illusion, generated moment by moment, as much a product of code as the stars and seas. The thought is unsettling, but perhaps it need not be. If the experience of consciousness feels real, if it allows for wonder, for love, for reflection, then its origin may not matter. The night offers no resolution. Consciousness remains the most intimate mystery, and perhaps the most untouchable. It is the one thing each being knows with certainty, the fact of being aware, yet it is the one thing science and philosophy cannot fully explain. Emergent, or fundamental, simulated, or primary, it endures, quiet and luminous. The question lingers like a soft flame. Is consciousness the outcome of the simulation, or is the simulation the outcome of consciousness? The thought flows into the subtle realm of the observer, the strange truth that in physics, watching can change what is seen. In quantum experiments, particles do not reveal definite states until they are measured. A photon behaves like a wave until it is observed. Then it behaves like a particle. The act of looking, of measuring, seems to alter the outcome, as though reality itself waits for attention before deciding what it will be. This phenomenon, called the observer effect, unsettles the idea of a fixed world. If the universe were purely mechanical, its state should be independent of observation. Yet the experiments whisper otherwise. They suggest that perception is not passive, but participatory, that to observe is to help shape what is observed. Could this be another sign that reality is more like a simulation than a machine? In digital worlds, nothing exists in full detail until it is rendered. A landscape in a video game is not continuously simulated across its entire horizon. Only what the player sees is calculated, generated in real time, while the rest lies dormant, waiting to be called into view. Could quantum uncertainty be the universe's way of rendering? Could particles wait in probability until observation calls them into actuality? The thought is not proof, only suggestion, yet it resonates. The cosmos may not be pre-written like a book. It may be dynamic, responsive, interactive. Consciousness may not simply float within reality. It may draw reality into being, one observation at a time. This raises quiet questions about scale. Does the universe render only what individuals perceive? Or is there a collective rendering, reality sustained by the combined act of all observers together? Perhaps each being carries part of the responsibility, weaving the world through attention, like countless brushstrokes painting the same canvas. And what of the unseen? Forests where no one walks, oceans where no one dives, galaxies too distant for any telescope. Do they exist fully, or do they wait as probability, as possibility, until observation reaches them? From within the simulation, the answer cannot be known. Perhaps they exist regardless. Perhaps they flicker only into partial being, like background processes conserving energy. The thought is strange, but strangely consistent. Yet even outside physics, the observer effect touches life. A gaze changes the one observed. A word shifts the meaning of silence. To be witnessed is to be transformed. Perhaps this is why attention feels so powerful, why presence carries weight. In the smallest particles and the largest human moments, observation alters reality. Still, humility remains. Perhaps the observer effect is not about perception at all, but about interaction. Measuring requires instruments, and instruments disturb. The disturbance may not be mystical, only practical. Yet even so, the metaphor lingers, carrying meaning beyond its technical frame. Whether literal or symbolic, the observer seems inseparable from the observed. The night holds this thought with patience. Reality continues to flow, whether rendered or continuous, whether waiting for observation or not. Yet the question drifts onward, soft as breath. Is the universe complete without the observer, or does it bloom into being only when it is seen? The thought lingers on the resemblance between the world of nature and the world of machines. Computation was born from human ingenuity, yet everywhere in the cosmos patterns emerge that look strikingly similar to the operations of code. Nature imitates computers, and computers imitate nature until the distinction begins to blur. Consider the branching of rivers across a landscape. Each tributary divides and subdivides, following paths of least resistance, forming a tree-like pattern. The flow of electricity across a circuit board looks the same, channels branching, reconnecting, distributing energy with elegant efficiency. One is carved by water and stone, the other etched in silicon and metal, yet both obey the same logic of networks. The same is true of fractals. A coastline from above reveals curves that repeat in smaller and smaller scales. Lightning branches, in patterns mirrored by neurons in the brain. In computation, fractals are generated by simple formulas, repeated iterations producing infinite complexity. Could nature itself be iterating? Could reality itself be the outcome of simple instructions, repeated endlessly until forests, clouds, and galaxies appear? Information theory offers another reflection. At the root of every digital process lies the bit, the choice between 1 and 0, presence or absence. Strangely, physics at its foundation also seems to deal in such choices. Particles exist or they do not. Energy is quantized All or nothing, yes or no. Some physicists suggest that the universe may be made not of matter, but of information, that reality is fundamentally data, woven into patterns we experience as space and time. If so, then the parallel deepens. The cosmos is a vast computation, unfolding moment by moment. Every star is a calculation, every orbit is an algorithm, every breath is an operation in progress. The simulation hypothesis becomes less a wild idea and more a natural extension of what is already known. That information lies at the heart of being. But the mirror reflects both ways. Computers, too, imitate life. Artificial intelligence learns in ways that echo evolution, generating new possibilities through variation and selection. Programs simulate weather, the spread of forests, the formation of galaxies. Machines become models of nature, and nature becomes the model for machines. If the two are so deeply entwined, is it possible that one is born from the other, that the universe is itself a machine, or that machines are rediscovering the principles of the universe? And yet there is still a difference, or at least the appearance of one. Computation feels mechanical, deterministic, bounded by rules. Nature feels alive, open, surprising. A program produces what it is told to produce, while a forest grows, with unpredictable grace. But is this distinction real, or is it only a matter of scale? A program complex enough may appear alive. A forest simple enough may appear deterministic. Perhaps the two are not opposites, but reflections of one another, different expressions of the same underlying order. The question lingers, not with urgency, but with softness. When we look at computers, are we seeing something invented or something remembered? Are we creating machines in our own image, or are we uncovering truths already woven into the fabric of reality? The mirror offers no clear answer. It only shows that computation and nature share a face, and that face may be the face of the simulation itself. The night holds this image gently, like a screen glowing in darkness, like a forest stretching into shadow. Two mirrors reflecting one another endlessly. And the question drifts like quiet code. Is the universe imitating a computer, or is the computer imitating the universe? The mind turns back toward the earth, not as surface or scenery, but as memory itself. The planet seems quiet, yet it remembers everything. Its oceans store the cycles of climate. Its rocks keep the trace of vanished forests, buried seas, lost continents. Even the sky carries memory in its composition, the breath of ancient organisms still present in oxygen that fills the lungs. This memory is not like human memory. It does not unfold as stories or images. It is slow, heavy, patient. It lies in layers, each stratum pressing upon the next, each telling a fragment of a larger tale. Volcanic ash becomes a page, recording an eruption. Coral reefs become limestone, a record of oceans long gone. Ice traps air, keeping bubbles of atmosphere sealed for hundreds of thousands of years. All of these are archives, quiet and unassuming, waiting to be read. If reality is a simulation, then perhaps these archives are more than natural. They may be the system's way of storing state, ensuring continuity from one moment to the next. In computers, memory is not optional. It is the condition of persistence. Without it, a program could not flow, could not sustain its own unfolding. Perhaps the Earth itself functions in this way, carrying memory in its material body so that the simulation of life remains coherent. The thought lingers on fossils. A leaf pressed into stone is both delicate and enduring. Fragile veins captured in mineral detail. Bones transform into crystal, becoming both artifact and record. To hold. A fossil is to hold memory, not just of a creature, but of the world in which it lived, the temperature, the climate, the chemistry of the air. Memory is never solitary. It is always relational, always part of a greater weave, and memory can fade. The crust subducts into the mantle, erasing whole chapters as tectonic plates sink and melt. Sediments wash away. Rivers cut new paths. Glaciers grind mountains into powder. Entire ages vanish, overwritten like text on a reused page. Just as digital memory may be cleared, just as files may be deleted, the Earth forgets. This forgetting is not error but process, the way the system refreshes itself, the way it remains alive. Human beings sense this fragility, and so they build their own forms of memory. They carve symbols into stone, paint stories on cave walls, press words into clay tablets, print books, record sounds, capture light in photographs, store information in silicon. These archives, too, are vulnerable, lost to fire, water, entropy, the slow drift of time, but the impulse is the same: to resist erasure, to carry forward traces of being. The mirror deepens. Earth as archive, humanity as archivist. Both are forms of memory within memory, layers within layers. And if this is a simulation, then perhaps the act of remembering is not accidental. Perhaps memory is the point. Each trace left behind becomes part of the program, each attempt at preservation another line in the code. Yet memory does not guarantee permanence. Even digital systems degrade, data corrupted, formats obsolete. Perhaps no archive lasts forever, but perhaps permanence is not necessary. Memory need only endure long enough to shape the present, to carry meaning forward, to give continuity to what comes next. The thought settles like dust on stone. The Earth remembers, and it forgets. It writes and rewrites its own archive, patient, as time itself. Whether this is natural geology or simulated storage, the result is the same: a world filled with traces, some visible, some hidden, some already lost. To walk upon the Earth is to walk upon memory, even when one does not see it. The night holds this truth gently, a reminder that memory is everywhere. Every stone, every breath, every ripple of water carries echoes of what came before. The question remains: is this memory simply matter, or is it the simulation's way of keeping the story alive? The thought moves deeper into those layers of Earth's archive, and it lingers on a possibility both haunting and serene: the presence of fragments from forgotten worlds. Civilizations may have come and gone, leaving behind only faint traces, threads woven into stone so subtly that they appear natural. What if life has bloomed not once but many times, rising into complexity, reaching unknown heights, and then fading into silence? Imagine a world in the distant past, millions of years before the first human walked. Perhaps intelligence flourished there, beings who built, who wondered, who left their mark in ways that would have seemed enduring. Yet time is relentless. Oceans rose, continents shifted, glaciers advanced and withdrew. Everything fragile would have dissolved. Even the mighty bones of dinosaurs are rare finds, and they lived far more recently than such a civilization might have. How then could memory of them remain? The Silurian hypothesis whispers again here: if such worlds existed, their signs would be subtle. A thin layer of chemical residue, an unusual pattern in carbon isotopes, a disturbance in sediment layers too, regular to be chance. Clues that might look natural, unless one were searching for them with a different question in mind. The Earth is a patient eraser, yet it does not erase perfectly. Fragments may linger, overlooked because no one expects to find them. And yet, what if these fragments are not physical at all, but structural? If reality is a simulation, then earlier iterations may leave behind faint echoes in the code itself, patterns of recurrence, glitches, déjà vu, the strange sense that some events feel familiar though they cannot be remembered. Perhaps fragments of forgotten worlds live not in stone, but in consciousness, woven into the very fabric of being. The imagination stretches further. What if myths are such fragments? Stories of floods, of lost golden ages, of civilizations swallowed by the sea. Atlantis, Lemuria, countless others. Perhaps these are not inventions, but echoes, cultural memories of worlds erased long ago, lingering faintly in the simulation like shadows on old parchment. They may not be literal, yet they carry weight, as though whispering of deeper histories no longer visible. Even science carries its mysteries. Mass extinctions whose causes remain debated, climate shifts that appear sudden, gaps in the fossil, record where life seems to pause or transform in ways not fully explained. Could some of these be scars of forgotten worlds, hidden chapters written over but not completely erased? Or are they only the natural rhythms of Earth, cycles of change and renewal? To consider this is not to claim certainty, it is to invite humility. Human history is brief, 10,000 years of cities, perhaps 100,000 of culture compared to billions of years of Earth's unfolding. Against such a scale, humanity is but a blink. Could other blinks have occurred before, bright and brief, forgotten except for faint traces? The Earth would not tell. The Earth does not keep history as humans do. It remembers differently, and it forgets differently, and so the thought remains suspended, the possibility of fragments, visible or invisible, written in rock, in myth, in code, in silence. Whether they exist or not, they remind us of time's immensity, of the fragility of civilizations, of the mystery of beginnings and endings. The night deepens, and the Earth turns quietly, carrying its layered memory. If forgotten worlds have left fragments, they are scattered, faint, patient, waiting, perhaps, for eyes to notice, or perhaps content to remain forever hidden. The thought lifts upward once more, away from stone and fossil, into the wide and nearly silent expanse of space. If civilizations once existed here on Earth, or if they exist elsewhere among the stars, then why is the cosmos so quiet? This question, known by some as the Fermi paradox, lingers like a hush after a question asked too loudly. Where are they? The others? If the galaxy holds hundreds of billions of stars, many with planets, why do no voices reach us? Perhaps the silence is natural. Civilizations may be rare, fragile, easily broken by their own limitations, lost before they ever learn to cross the dark. Or perhaps they are distant, scattered too widely across space and time for their signals to overlap with ours. The cosmos is vast, and a message might take thousands of years to arrive, perhaps longer than civilizations themselves endure. But the silence may also be something else. If reality is a simulation, then perhaps other civilizations are not rendered at all. In digital systems, only what is necessary is generated. A horizon in a program does not exist in full detail until approached. Perhaps Earth is the focus, the only simulation of life, while the rest of the cosmos is backdrop, convincing but empty. Stars shine, galaxies spiral, but they are set dressing, not inhabited, not meant to be. This possibility does not make the universe less beautiful. Even as backdrop, the night sky inspires awe, its silence a canvas for human imagination. Yet it reframes the question, is the absence of evidence an accident of scale, or a deliberate choice in the code? And yet, silence can also be signal. Lack of voices may itself be meaningful, a kind of negative space. Perhaps civilizations that do exist choose not to speak or are instructed not to, leaving Earth to believe it is alone. Perhaps the silence is protective, a way of keeping observers unaware of the greater system in which they exist. Still, there are anomalies that stir curiosity, peculiar signals detected and dismissed as interference. Stars whose dimming patterns, seem unusual, as if obscured by structures not yet understood. None are definitive, all are debated, yet each one awakens the same question. What if the silence is not absolute? What if faint signals do exist, hidden in the noise, or encoded, in ways not yet recognized? And beyond this is the quiet possibility that the simulation itself carries signals, not from other beings within it, but from its architects. Subtle messages woven into the background radiation, into mathematical constants, into the very fabric of physics. Perhaps the silence of the cosmos is not emptiness, but restraint, an intentional space left open, like the pause in a piece of music, allowing those inside to wonder. Silence is not nothing. It has texture. It has weight. It shapes experience as surely as sound. The silence of the universe may be vast and lonely, or it may be deliberate, a feature of the design. To those who listen, it becomes a presence, an invitation to imagine. The night remains still. The stars continue to shine without reply, and the question drifts onward. Is the silence of the cosmos absence, or is it a signal waiting to be heard? The thought turns inward again, into the quiet of solitude, into the feeling of being small in an immeasurable expanse. If Earth is a simulation, then what does it mean for those who dwell within it? What does it mean to be a simulated being? The idea at first carries loneliness, as though to be simulated is to be less real, to be cut off from whatever lies beyond. Yet, when considered more gently, the feeling shifts. For what is real and what is simulated if experience is the same? A simulated being loves, and the love feels true. A simulated being suffers, and the suffering carries weight. Joy, curiosity, wonder, all are vivid, all are lived fully. The distinction between constructed and original may not matter at all within the flow of experience. From the inside, reality is simply what is present, what is felt. And yet, the thought of separation lingers. If this is a simulation, then perhaps there are boundaries that cannot be crossed, edges where perception stops, horizons beyond which there is nothing rendered. Perhaps the loneliness of simulated beings is not only the absence of contact with other civilizations, but the absence of contact with whatever mind or system holds the simulation itself. If someone or something has built this world, then why do they not speak? Why does the code not reveal itself? Perhaps the silence is kindness. To live fully within a world requires believing in it. If the walls of the simulation were too obvious, if the machinery were visible, then the experience would be diminished. To feel love, to grieve loss, to gaze at stars with awe, all of this requires immersion. Perhaps loneliness is part of the design, a necessary veil that keeps beings inside the story, allowing them to live it without distraction. But loneliness can also be reframed. To be simulated may also be to be connected, for if this is code, then all beings within it share the same foundation, the same hidden threads. Just as entangled particles remain linked no matter how far apart, perhaps all simulated beings are bound by the deeper unity of their origin. Loneliness, then, is only a surface impression, while beneath it lies communion too deep to be seen. The imagination wanders further. If the simulation is designed, perhaps every being is observed, not in the way humans watch one another, but in the way a system tracks its processes. Every thought, every dream, every breath may be known at a deeper level, not in judgment but in presence. If so, then no being is ever truly alone. Each life is carried, recorded, remembered in the unfolding of the program. Still, the question lingers: if simulated, does that make existence less meaningful, or more? Less because it feels derivative, secondary, dependent. More because it means that existence was chosen, that someone or something wanted it to be, crafted it with care. The answer, perhaps, lies not in either direction, but in the experience itself. Meaning is not diminished by origin. A rose does not lose its beauty because it grew in a garden rather than in the wild. The night cradles this thought with stillness. To be a simulated being is to be alive within mystery, to feel both loneliness and connection, both smallness and significance. And the question drifts onward, soft as a breath. Does it matter whether life is simulated, if the experience of living is real? The thought bends gently now toward the question of purpose. If reality is a simulation, then why does it exist? Why is there something instead of nothing, a world instead of silence? The question is not urgent, not demanding, but it hovers in the stillness, as if the very act of wondering is itself part of the design. Purpose can be imagined in many ways. Perhaps the simulation is an experiment, a way for beings beyond to study what emerges when matter follows certain laws. Perhaps it is a laboratory of possibilities, a place where countless scenarios unfold, each tested, each observed. In this view, the universe is a research project, and those within it are the data, living out variations of existence. Or perhaps it is not study, but play. Children build sand castles, not for knowledge, but for delight. They construct worlds of imagination, kingdoms that exist only for a moment, yet feel complete while they stand. Could reality be such a creation, an act of play by minds beyond comprehension, not seeking answers, but simply enjoying the unfolding of beauty, complexity, and surprise? There is also the possibility of remembrance. As earlier thought suggested, perhaps the simulation is built to recall, to reconstruct what has been lost. If so, then purpose lies in continuity, in the desire to keep memory alive. Every star, every ocean, every heartbeat may be part of a vast archive, a way of preserving what otherwise would have vanished. But purpose may not be human at all. To ask why may be to assume too much, to project human needs onto something that may not share them. Perhaps the simulation has no purpose beyond itself. Perhaps it exists because it can, unfolding endlessly without need for reason, like a flower, blooming without audience, or a river flowing without destination. The universe may simply be. Still, the sense of purpose feels present, even if undefined. The fine-tuning of physical laws, the elegance of mathematics, the persistence of consciousness, all invite the thought that something is meant, even if the meaning cannot be named. Whether by design or by chance, the conditions of the world allow for life, and life allows for reflection, for wonder, for the very asking of this question. And so another possibility arises. Perhaps the purpose of the simulation is not external, but internal. Perhaps its meaning lies not in why it was made, but in what beings within it experience. To love, to create, to question, to feel the passage of time. These may be the purpose themselves. If so, then to ask the question is to fulfill it. The act of wondering may be the very reason the world exists. The thought softens again. Purpose may not be a single answer, but a spectrum, shifting depending on perspective. To some it is experiment, to others play, to others memory, to others simple existence. None cancels the others. All may be true or none. The universe offers no certainty, only the invitation to wonder. The night receives this question as it receives all questions, without reply, but with patience. And the thought drifts onward. If the universe is a simulation, then perhaps its purpose is not something to be solved, but something to be lived. The thought stretches outward again, toward the weight of infinity. If reality is a simulation, and if it was created by another reality, then what of that one? Is it real, or is it itself simulated by another? The question expands endlessly, a chain without beginning or end. Each creator may only be a creation. Each architect may be a figure inside someone else's design. This recursion has no anchor. If one accepts that our world is simulated, then the next question follows. Who simulated the simulators? And if they are simulated, then who simulated them? The spiral continues, folding back upon itself like mirrors reflecting mirrors, each image vanishing into smaller and smaller depth. Infinity is both comforting and unsettling. It suggests that existence never ends, that there is always another layer, always another beyond. Yet it also suggests that there may be no foundation, no ultimate reality, only layer after layer, each as provisional as the last. In such a cosmos, there is no bottom to reach, no final ground to stand on. There is only the endless descent or ascent of simulation upon simulation. Perhaps this is not a flaw, but a feature. Infinity allows every possibility to exist. In an infinite chain, nothing is excluded, nothing is final. Each layer is complete in itself, yet part of a larger whole. Meaning may not lie in reaching the bottom, but in dwelling within the layer. One inhabits, living it as fully as if it were the only one. Physics already offers hints of such recursion. Fractals repeat endlessly, their patterns self-similar at every scale. The Mandelbrot set contains infinite detail, each zoom revealing shapes that echo the whole. Galaxies spiral like shells, shells spiral like galaxies. Perhaps reality itself is fractal, each layer containing others, each one echoing the structure of the rest. And yet, infinity can be dizzying. To imagine never reaching an end is to confront the possibility that final answers do not exist. But perhaps that is not a flaw either. A story without an ending is not broken, it is eternal. A question without an answer is not empty, it is alive. Infinity ensures that wonder never runs out, that curiosity never exhausts itself, that being always opens further. If there is an infinite chain of simulations, then perhaps every layer is both creator and creation. We may be simulated by others, yet we too may simulate worlds of our own, building realities within realities, carrying the spiral forward. In this way, infinity is not only vast but participatory. Every being contributes, knowingly or not, to the endless unfolding. The thought rests for a moment. Infinity is not something to grasp, but something to feel. Like the ocean, it cannot be held, only entered. Like the night sky, it cannot be contained, only witnessed. Its weight is immense, but its silence is gentle. And so the question remains, if there is no first and no last, if every reality is part of an infinite spiral, then where are we within it? The night does not answer. It only extends, horizon after horizon, without end. The thought drifts into the darkness itself, the quiet stretches of space where there are no stars, no galaxies, only a vast void. The human eye sees this as emptiness, a black expanse between points of light. Yet even here, questions linger. Is the void truly nothing? Or is it the canvas upon which everything else is painted? If the universe is a simulation, then perhaps the void is not emptiness at all, but background. In digital landscapes, what is not rendered is left blank, a placeholder, a space for the eye to rest. Perhaps cosmic darkness functions the same way, a way to frame the stars, to give shape to galaxies, to balance the brilliance of light. Without it, the universe might be blinding, featureless, overwhelming. The void gives contrast, and through contrast, meaning. Yet physics tells us that emptiness is never truly empty. Even in the depths of space, quantum fields fluctuate. Virtual particles appear and vanish, borrowing energy from nothing, returning it just as quickly. The void hums with possibility, restless beneath its silence. Could this be the operating field of the simulation, the fabric upon which everything else is calculated? Not absence, but the hidden background process, the code running invisibly beneath the surface. And what of dark matter and dark energy, unseen yet dominant? They make up most of the cosmos, yet they cannot be directly observed. They are inferred only by their effects, by the way galaxies move, by the way space expands. To human senses, they are invisible. To human instruments, they remain elusive. If the universe is simulated, could these be the scaffolding, the framework required to sustain the visible world? Could dark matter be the unseen structure of the code, holding galaxies in place? Could dark energy be the program's expansion, pushing time and space outward to maintain consistency? The void is also silence. No sound travels through it, no. Air carries vibration, and yet silence is not empty. It has texture, weight, presence. To stand beneath the night sky is to feel that silence, to sense that it is not absence, but depth. Perhaps the void is not a blank, but a reservoir, holding mysteries not yet revealed. For human beings, darkness often carries unease. Yet here, in the scale of the cosmos, it carries calm. The stars shine because the darkness allows them to. Galaxies glow because the void surrounds them. The emptiness is part of the beauty, part of the balance. The thought lingers. If the void is backdrop, is it also boundary? Does it stretch without end, or does it curve around, enclosing the simulation like the black walls of a stage? Is there something beyond it, unseen, unreachable? Or is the void itself the final layer, the silent horizon of being? The night continues. In stillness. Darkness stretches outward in every direction, infinite to the eye, whether infinite or not. And the question drifts softly across it. Is the void nothing, or is it everything? Canvas, code, silence, and frame. The thought now turns to time, that quiet river in which every life drifts. To human senses, time feels smooth, unbroken, flowing without pause from moment to moment. Yet physics, and perhaps the simulation itself, suggests something more fragile. What if time is not continuous at all, but stitched together from countless fragments, refreshed moment by moment, frame by frame? Imagine a film reel. Each frame is still, unmoving, but when played in sequence it creates the illusion of motion. The eye accepts it as seamless, though it is nothing more than many images shown quickly, one after the other. Could reality be the same? Each instant discrete, each moment its own frame, flowing so quickly that the gaps vanish into the illusion of continuity? If reality is a simulation, this would make sense. No program calculates every detail continuously. Instead, it updates, in steps, cycles, instructions processed one after another. To the system, time is not a river, but a series of ticks. To the beings within, it feels smooth, because perception itself is built to smooth the edges. Perhaps what is called the present is simply the latest rendered frame, refreshed in perfect silence, and yet, even outside the idea of simulation, physics whispers of time's fragility. At quantum scales, there may be a smallest unit of duration, the Planck time, beneath which before and after lose meaning. In relativity, time bends and stretches with gravity, running slower near massive bodies, faster in emptier spaces. Time is not absolute. It shifts, flexes, reshapes itself. Already the river is not as smooth as it seems. Consider memory. The past exists only as traces in the mind, as echoes in material archives. The future exists only as expectation, imagined but not yet real. All that truly exists is the present, and yet the present itself is elusive, already gone as soon as it is noticed. Perhaps the present is not continuous at all, but a series of moments stitched together, giving the impression of flow where none exists. If time is fragile, then what of destiny? What of continuity? Does life move forward because time is inherently flowing, or because the simulation updates, carrying each process into its next state? Perhaps what is experienced as growth, as change, is simply the rendering of successive frames, each one recalculated with exquisite consistency. This fragility invites wonder. If time is constructed, then who or what constructs it? If it is coded, then who chose its speed? The tick of time feels universal, yet different choices could have been made. Seconds could be longer or shorter, the pace of existence slower or faster. If time is part of a simulation, then its rhythm may not be absolute but adjustable, like the settings of a program. And yet, to those within, time is all there is. Fragile or not, discrete or continuous, it carries every breath, every heartbeat, every sunrise. Even if built from frames, the illusion is complete, seamless, beautiful. Whether river or mosaic, whether flow or refresh, time remains the medium of life. The night holds this thought gently, without haste. The stars move across the sky, though their motion is only apparent, only the earth turning slowly in darkness. A clock ticks softly somewhere, each moment distinct, yet merging into continuity. And the question drifts onward. Is time a flowing river or a sequence of fragile steps, refreshed in silence by the code beneath? The thought now lingers on the possibility of disruption. If reality is a simulation, what happens when the code falters? Not a collapse of the whole, not a breaking of the world, but small tremors, tiny irregularities that slip into experience like hairline cracks in glass. People sometimes call these moments glitches, a sensation of déjà vu, the uncanny feeling of living a moment twice. A coincidence too exact to ignore, as though probability itself bent for an instant. A dream so vivid it bleeds into waking, as if two realities brush together. Most pass unnoticed, explained away, forgotten. Yet they leave behind the faintest question. Was that the world, or was that the code? In digital systems, glitches are often unintentional. A line of data misread, a loop repeating when it should end. The result can be strange. A texture flickering, an object appearing twice, a scene resetting without warning. In the simulation of reality, could déjà vu be such a loop, a brief reset, a fragment reloaded before the flow resumes? But glitches need not be errors. Sometimes they are features disguised as anomalies, deliberate injections of unpredictability. A program without variation would be static, lifeless. To feel real, it must contain surprise. Perhaps coincidences. And irregularities are not flaws but textures, part of the richness of the design. Life feels fuller when it contains the unexpected. And what of inspiration, the sudden arrival of an idea from nowhere, a phrase, an image, a melody appearing fully formed, as though whispered by something unseen? Could such moments be the simulation's way of updating, inserting new data into the flow? Or are they simply the natural creativity of minds, connections firing in silence? Both possibilities carry wonder, for both suggest that reality is more porous, more open than it seems. Even physics contains what could be glimpses of broken seams. Quantum particles behaving unpredictably, as though refusing to follow the neat rules of determinism. Constants of nature that appear too precise, too unlikely, as if someone set them intentionally. Entropy itself, the tendency of order to dissolve, could be read as a kind of decay in the system, a slow wearing down of the code. Yet the simulation, if it is one, remains seamless. The glitches, if they exist, are subtle, fleeting, easily folded back into ordinary life. To notice them is not to prove them, only to wonder. Perhaps the very subtlety is intentional, leaving just enough irregularity to spark curiosity, but never enough to break immersion. There is beauty in this fragility. A reality without mystery would be too perfect, too complete. It is the anomalies, the strangeness, the unexplainable, that give texture, that open space for imagination. Whether coincidence or glitch, inspiration or error, these moments remind beings that the world is not closed. It contains more than can be measured, more than can be known. The night is quiet. Somewhere a thought repeats. Somewhere a pattern reappears. Somewhere a dream overlaps with waking. The world continues, steady and seamless. Yet the question drifts onward. When the fabric flickers, however briefly, is it revealing a flaw in the code or a glimpse of the vastness behind it? The thought turns now toward the unfolding of life itself. From the simplest molecules to the vast complexity of ecosystems, existence seems to climb steadily upward, experimenting, diversifying, evolving. What if this process, which appears natural and spontaneous, is in fact the logic of a simulation, an algorithm of increasing complexity, tested and refined across eons? Evolution, as observed, is iterative. Mutations arise, some vanish, some persist. Traits combine, adapt, spread, or fade. Over immense spans of time, single-celled organisms give rise to plants, animals, consciousness itself. The process is open-ended, yet structured, as though life is a program designed to explore every possibility, to see what emerges when rules of variation and selection are allowed to play endlessly. In digital systems, similar methods exist. Genetic algorithms, inspired by biology, allow computers to solve problems by creating generations of solutions, selecting the best and combining them into new forms. From randomness, order arises. From simple instructions, complexity blossoms. What looks like design can emerge without a designer, as though the rules themselves are sufficient. Could Earth be running such a process, a simulation of evolution itself? Imagine the earliest seas, filled with molecules drifting and colliding. Perhaps the simulation began here, not with life fully formed, but with the rules of chemistry, left to unfold. Molecules became chains, chains became cells, cells became networks. Each step not predetermined, but possible within the rules. Perhaps the beauty of the simulation lies not in control, but in emergence, allowing life to surprise even its creators. And still, the pace of evolution invites questions. Life persisted for billions of years as single cells. Then suddenly, in geological terms, it exploded into complexity. The Cambrian seas filled with creatures strange and varied, as though the system accelerated, generating forms rapidly, testing the boundaries of possibility. Was this a natural threshold, or was it a moment of adjustment in the code, an expansion of the simulation's parameters? Even extinction can be seen through this lens. When asteroids strike, when climates shift, when species vanish, evolution does not end. It resets, creating space for new experiments. In computation, this is known as pruning, clearing paths to allow different outcomes. Perhaps mass extinctions are not only tragedies but functions, necessary to keep the simulation dynamic, to prevent stagnation. And what of intelligence? Consciousness emerges late, fragile, uncertain. Was it inevitable, or was it one branch among countless others, chosen by chance or by adjustment? If the simulation seeks awareness, then perhaps every path leads eventually toward minds that wonder, that reflect, that ask questions such as these. If not, then perhaps awareness is only one more experiment, no more central than wings or leaves, destined to vanish or transform. Yet, to those who live it, awareness feels significant. To think, to love, to imagine, is to participate in something profound. Even if life is a simulated process, even if evolution is an algorithm, the experience remains authentic. Pain still hurts, joy still uplifts, beauty still stirs the heart. The origin may be code, but the unfolding is real. The night holds this thought with calm. Life continues to evolve, in bodies and in cultures, in technology and in imagination. The simulation, if it is one, is still running, still exploring, still generating new forms. And the question drifts onward. Is evolution the creativity of nature or the creativity of code, an endless experiment, playing patiently across the ages? The thought now drifts to the mystery of endings, to the question of death. If life is part of a simulation, then what happens when a process stops running? What does it mean for a consciousness to cease, for a body to no longer participate in the flow of the code? From within, death feels like the great unknown. It is the horizon no one can cross and return from unchanged. For those who remain, it is absence, the silence of a voice that once spoke, the emptiness of a presence that once filled space. But for the one who departs, what is it? Is it erasure, the program ending and leaving nothing behind? Or is it transition, a transfer of data to another state, another system, another layer of the simulation? In digital worlds, processes do not always vanish when they stop running. Sometimes they are stored, archived, kept as records. Sometimes they are reset, rerun, reloaded in a new context. Could consciousness be similar? Perhaps death is not deletion, but migration. Perhaps the awareness that feels so singular is not tied to the body at all, but to deeper structures, preserved beyond the visible frame. And yet, the natural world suggests another truth. Bodies return to soil, their matter redistributed, their energy carried onward. The cycle of life continues without pause. Death feeds life, endings are beginnings. Even in a simulation, this pattern might hold. Nothing wasted, everything recycled into new forms. The individual may vanish, but the whole continues, seamless, eternal. Philosophy adds another layer. If consciousness is fundamental, as some traditions suggest, then it cannot be destroyed. It is not generated by the body, but expressed through it, like light through a window. When the window breaks, the light continues, shining elsewhere. Death, then, is not an end, but a shift. The simulation may change form, but awareness remains. But if consciousness is emergent, built from the processes of the brain, then death may be the halting of those processes, the shutting down of a program. Awareness may dissolve, never to return, just as a flame vanishes when fuel runs out. This view is stark, yet it, too, carries a strange peace. For in dissolution, suffering ends. In finality, there is rest. Still, the possibility lingers that death is not uniform, not the same for all. Some traditions imagine rebirth, the recycling of consciousness into new forms, new simulations. Others imagine transcendence, the merging of individual awareness back into the larger whole. Perhaps the simulation allows for many endings, many transitions, none absolute, all part of the unfolding. To live with death is to live with uncertainty. Yet uncertainty is not absence. It is space for wonder, space for humility. Death reminds beings that time is precious, that moments are finite, that life is fragile and therefore luminous. Whether simulated or natural, the effect is the same. an urgency to love, to create, to cherish. The night holds death without fear. Stars burn and extinguish, galaxies merge and dissolve, planets form and vanish. All things end, and yet the cosmos continues. If this is simulation, then perhaps even death is only part of its design, a necessary rhythm, a way of keeping the flow alive. And the question drifts onward, soft and unhurried. When the process stops, is it the end of awareness, or only the end of one chapter in an endless simulation? The thought bends now toward the edge of knowledge itself, the horizon beyond which no understanding seems able to pass. Every age of discovery carries its own boundaries. Lines drawn not by imagination, but by the limits of what can be measured, tested, known. Beyond those lines, silence begins, an expanse where certainty dissolves into wonder. In cosmology, such horizons are literal. Light travels only so far in the age of the universe, and beyond that distance, nothing can be seen. The cosmic microwave background marks one such horizon, a wall of ancient light, the farthest image science can capture. Beyond it lies the origin of time and space themselves, unreachable from within. No matter how powerful the telescope, no matter how clever the theory, what lies beyond remains hidden. In black holes, horizons take another form. The event horizon is a boundary past which no signal returns. To approach it is to approach a silence so complete that information itself vanishes. What happens within remains unknowable, not because of unwillingness, but because of the structure of reality. Horizons are not obstacles to be overcome. They are woven into the fabric of the cosmos. If reality is a simulation, then these horizons may be more than natural. They may be boundaries of rendering, limits beyond which detail is unnecessary. Just as a digital landscape contains only what is visible to the player, perhaps the universe contains only what is needed, only what can be reached. Beyond the horizon, there may be nothing at all, or only potential, waiting to be called into being. But even within everyday life, horizons exist. The mind cannot remember beyond early childhood. The senses cannot detect all wavelengths of light, all vibrations of sound. Even thought itself meets its edges, paradoxes it cannot solve, infinities it cannot fully comprehend. Knowledge expands, but the horizon expands with it, always retreating, always beyond reach. Perhaps this is not limitation, but gift. A world without mystery would be a closed system, finished, complete. Horizons keep the story alive. They ensure that wonder never runs out, that curiosity never exhausts itself. They remind beings that no matter how much is known, something greater always remains. The horizon of knowledge may also be protective. To know everything at once would be overwhelming, unbearable. Horizons soften the immensity, revealing the world piece by piece, allowing discovery to unfold slowly, gently. If the universe is simulated, perhaps this unfolding is intentional, a way of guiding awareness through stages, like pages of a book revealed one at a time. And so, each horizon carries both finality and promise. It says, "Here is where you stop," and it says, "Beyond this, there is more." The paradox is that both are true. To reach the horizon is to find both an ending and an opening, both a silence and an invitation. The night embodies this perfectly. The stars shine, yet beyond them lies darkness unseen. Knowledge reaches far, yet beyond it lies mystery untouched. And the question lingers like a breath. Are horizons the limits of reality, or the edges of a simulation, carefully placed to keep the story unfolding? The thought drifts now to the edges of perception, the boundaries where reality feels soft, as if it might dissolve into something else if touched too closely. Every being moves within limits. of sight, of sound, of understanding. Beyond those limits, the world continues, but unseen, ungrasped. What if reality itself is shaped by these boundaries? Not infinite in clarity, but gentle at the edges, blurred like watercolor fading into paper. Consider the horizon at sea. From the shore, the ocean stretches outward, vast and complete, until it meets the sky in a seamless line. Yet the horizon is not real. It is perspective, a limit of vision. Sail beyond it, and the world continues. Always the horizon retreats, always just out of reach. Perhaps all of reality is such, appearing, complete but always limited by perception, always soft at the edges. In dreams, this softness is clearer. A dream unfolds with vivid detail where attention rests, but the background remains vague, undefined until needed. A forest may appear full, but look closely at its edges and the shapes blur, dissolve. Could waking life be similar? Perhaps the world is rendered in detail where attention falls, while the rest lies dormant, only potential until noticed. The soft edges are not flaws but efficiencies, the way the simulation conserves itself. Even in waking perception, the softness is present. Peripheral vision fades into blur. Colors dim at the edges of sight. Sound diminishes with distance, dissolving into silence that may not be empty but simply beyond range. Memory, too, has soft edges, the past recalled imperfectly, fading into haze. The future is softer still, known only as possibility, never in focus until it arrives. Physics offers its own horizons of softness. Quantum uncertainty means that at small scales, things cannot be fully known. Position and momentum blur. Existence itself becomes probability. The edges of certainty dissolve, replaced by a cloud of possibility. Reality itself, at its foundation, seems unwilling to be sharp. If this is a simulation, then perhaps the softness is deliberate, a feature of design. Sharp edges are brittle, easy to break. Soft edges flow, adapt, bend. A world with blurred boundaries may be more resilient, more immersive. It allows beings to believe in its continuity without ever noticing its limits, but even if not simulated, softness holds meaning. It reminds us that life is not absolute, not fixed. It is fluid, shifting, full of mystery. The inability to see clearly beyond the edges does not diminish the world. It deepens it, inviting wonder, inviting trust in what cannot be fully known. The thought settles gently. Perhaps reality is not a complete and perfect structure, but a tapestry woven as needed, with edges that dissolve into possibility. Perhaps the softness is not absence, but potential, the space from which new forms emerge. The night holds this truth in its darkness. Stars are sharp points of light, but between them lies a sky that seems endless, undefined, soft. And the question drifts onward. Do the edges of reality blur because they are incomplete, or because they are infinite, dissolving into mystery beyond perception? The thought turns gently toward paradox, that soft territory where opposites meet without canceling each other. If reality is a simulation, then knowing it may change nothing at all. For to those inside, the world feels real regardless of its origin. The paradox is that both can be true at once. Reality may be simulated, and yet it is still reality. Consider a painting. To the viewer, the colors, the shapes, the textures evoke beauty and emotion. It does not matter that the mountains on canvas are not mountains, that the sea is pigment rather than water. The experience of looking is authentic. The painting is not diminished by being representation. It is meaningful because it is lived through perception. In the same way, perhaps a simulated world is no less real. It exists as experience, and Experience is reality to those who feel it. Another paradox lies in choice. If every moment is coded, every law predetermined, then are choices genuine, or are they illusions? Yet, from within, the feeling of choice is undeniable. To stand at a crossroads and decide is to live freedom, even if the decision is written into the code. Illusion or not, it shapes life as truly as any freedom could. Perhaps freedom is not about ultimate control, but about the authenticity of the experience. The paradox of meaning follows. If existence is simulated, then perhaps it was created for a purpose: study, play, remembrance. But even if no purpose exists, beings still create their own. Love still binds, art still flourishes, questions still rise. The paradox is that meaning may come from without, or it may come from within, yet in either case it is real to those who live it. Even mortality carries paradox. If death is final, then life is precious because it is fleeting. If death is transition, then life is precious because it continues. Either way, the value remains. Fragility and endurance both give weight to being. Paradox does not demand resolution. It invites acceptance, the gentle recognition that truth may not be singular, that opposites can coexist without canceling. A simulation may be real. An illusion may carry truth. Determinism may feel like freedom. Absence may contain presence. Perhaps this is the design of the simulation, if design there is, not to provide clear answers, but to hold paradox, to allow beings to live inside questions without exhausting them, to experience reality as both certain and uncertain, finite and infinite, illusion and truth. The thought softens. Paradox need not unsettle. It can be calming, even comforting. To rest in paradox is to rest in openness, to let the question remain, alive without needing it to close. The night embraces this quietly. Stars shine as both distant suns and points of light. The universe feels infinite, yet may be bounded. Life feels fragile, yet somehow enduring. And the question drifts on, unresolved and luminous. If reality is a simulation, then perhaps its greatest gift is paradox, the gentle truth that knowing changes nothing, and yet it changes everything. The thought curves now toward the spiral, that ancient symbol found in seashells, hurricanes, galaxies, and dreams. It is a form that suggests both expansion and return, endless growth and endless repetition. If reality is a simulation, perhaps it, too, is a spiral, an infinite nesting of worlds within worlds, each contained by another, each containing others still. To imagine this is to step into a dizzying recursion. Every time a civilization creates its own simulation, it adds a new layer to the spiral. Within that layer, beings may create their own, and so on, without end. Each world believes itself to be real, and in its own frame, it is. The spiral expands, but it also curves back upon itself, echoing the same questions in every layer. What is reality? Who made this? Why does it exist? Perhaps this explains the familiarity of such questions. They are not asked for the first time. They are echoes, passed down the spiral, each layer inheriting the same wonder from the one before. If so, then every thought of the simulation is part of the simulation, a recursive loop feeding itself endlessly. The spiral also carries symmetry. The smallest seashell mirrors the largest galaxy. The growth of a fern mirrors the unfurling of a storm. Scale does not matter, the form repeats. Could this be the signature of the simulation? A pattern embedded in every level, reminding those within that they are part of something greater, something endless? But what of the end of the spiral? Does it reach outward forever, or does it curve inward, looping back to its beginning. Perhaps the first creators are themselves created. Perhaps the spiral has no origin, no final anchor, but is self-sustaining, existing only as relation, as recursion. If so, then asking for a first cause may be futile. The spiral is the cause, endless and sufficient unto itself. The thought settles. Infinity need not be linear. It can curve, fold, return. A spiral contains both motion and stillness, both progress and repetition. It is endless without being boundless, complete without being closed, and so perhaps reality is not a straight chain of simulations but a spiral of them, each echoing the others, each different yet the same. A being may never step outside its own layer, but in the patterns of nature, in spirals of shells, storms, galaxies, it glimpses the shape of the whole. The night embraces this image. Stars swirl in galaxies. Clouds twist in slow rotation. Even the patterns of thought coil inward and outward like spirals in the mind. And the question drifts softly with them. Are we part of an infinite spiral, forever nested, forever reflecting itself? The thought begins to slow now, circling back toward stillness. After wandering through questions of code and cosmos, of memory and mystery, it rests on silence itself. If the universe is a simulation, then perhaps all of this, every star, every stone, every fleeting breath, arises from a source beyond perception. And yet, from within, it is whole. From within, it is enough. The spiral of speculation loosens, unwinding into quiet. The need for answers softens. What remains is not resolution, but presence. The experience of being here, in this moment, alive within a world that feels real because it is real, at least to those who live it. Silence is not emptiness. It is depth. Oceans rest in silence. Beneath their waves, forests hold silence in their roots, even as branches whisper. The night sky is vast silence, and within it, stars bloom like lanterns. The simulation, if it exists, is carried in silence as well, the unseen hum of code no louder than breath. Perhaps the greatest truth is not whether the world is simulated, but that it can be experienced with wonder. Whether designed or emergent, whether finite or infinite, the reality that surrounds us offers beauty, mystery, fragility. A rose opening in the sun, a child's laughter echoing in the air, a storm gathering on the horizon. These need no proof, no explanation. They are real as lived, and that is enough. The thought dissolves into stillness. It does not demand an ending, only a settling. The earth continues its turn. The stars continue their slow drift. Consciousness rests in the awareness of being, without needing to know why. The horizon keeps its patience. It waits at the edge of knowing, a soft line where detail thins and distance turns to whisper. In open country, it lies as a band of blue. At sea, it curves like a promise. In deep space, it folds into mathematics and light. A mind considers the cosmic kind of this line. Not a seam between land and sky, but between what can remain in conversation and what slips away beyond reply. The universe expands. Wavelengths grow. Space itself carries distant shores farther than any boat of light can row. In this gentle receding, a boundary appears that is not a wall, only a limit to how far presence can extend itself without losing coherence. Physics speaks of horizons that belong to observers. Accelerate, and a personal curtain rises behind, a Rindler veil that hides whatever falls outside the reach of signals. Approach a black hole and curvature grows steep. An event horizon gathers, not as a barrier of stuff, but as a line past which return becomes a story without verbs. Live in a cosmos with a patient outward push, and a cosmological horizon settles in the far distance, a ring of elsewhere that recedes as steadily as attention tries to draw near. None of these horizons forbid being. They only shape relations. They are budgets softly enforced, limits that keep causality intact and calculations sane. If reality runs on computation, such horizons feel like careful settings in an engine designed for grace. A rendering system will keep remote ridgelines in suggestion until a traveler approaches. It saves effort without stealing wonder. Perhaps the sky's far edge works similarly, preserving the plausibility of distant structures as equations and priors until attention asks for more. When a mind turns a telescope and gathers photons that have walked for billions of years, the world answers with more detail than it seemed to hold. The engine spends a little more, never hurried, never wasteful, and the near grows to include what once belonged to the far. The metaphor stays modest, but it invites a revision of desire. Not every edge is a summons to break through. Some edges are invitations to notice. The horizon says, here is the scale of now. It does not scold curiosity. It slows its breathing. Instruments extend the gaze. Sky-filling surveys, cryogenic. Eyes, interferometers stitched across deserts and seas, but they do not abolish the horizon. They braid more of the near into the living circle of the present. Beyond remains beyond, not from refusal, but from structure. The way night remains night even as lamps brighten a room. There is another kindness in this. A bound on information protects meaning from dilution. If all voices shouted into one another at once, pattern might dissolve into glare. Limits grant islands where story can take root. A tide pools between stones and life begins. A pocket of silence in a forest lets a single bird be heard. A finite light cone gives a species room to become itself without interference from an infinity of remote demands. The horizon acts like a frame the world chooses for itself, a margin that allows the picture to breathe. The thought of exit arrives then, old and bright, stepping outside the rules to look back at the machine from a balcony. The imagination conjures a developer console hidden among constellations, a maintenance hatch passing as a comet, a password nested in the primes. The images flicker and fade. If there is an outside, it does not call for invasion. If there are maintainers, they are not careless with ladders. A hosted world that succeeds must be safe for its inhabitants. It must resist casual breakthroughs the way a careful dream resists drafts. Still, edges teach. Event horizons speak about energy and humility. Cross with too little care and even light cannot help. Cosmological horizons teach patience and scale. Some answers will not arrive because there is no channel wide enough for them. Mathematical horizons, where proof stops and conjecture begins, teach courage wrapped in rigor. Step with the rope of method, not the leap of appetite. In each case, this line is less an ending than a relationship. Presence meeting its limits and learning to listen as those limits speak. The language of exits softens into the language of continuities. When a child asks where the sky ends, the answer is not a place but a change of medium. Blue into black, air into vacuum, daylight into dark. If a civilization asks where reality ends, perhaps the reply follows the same grammar. What ends is not being, but a set of usable assumptions. Past a certain speed, simultaneity phrase. Past a certain density, geometry shifts. Past a certain distance, signals cannot keep company. The game continues, but the rulebook turns a page. From this view, outside becomes a limit case already present within inside, the way the calm at the center of a storm is made, by the wind that surrounds it. The mathematics that describe horizons also describe symmetries and conserved quantities, the quiet efficiencies that let complexity exist at all. If there is maintenance, it looks like the persistence of principles, locality where it matters, non-local ties where they do not break causality. randomness rich enough to seed novelty without erasing structure, constants tuned so that stars burn long and chemistry makes long sentences out of simple alphabets. With this held, attention turns to ordinary horizons. The end of a day, the soft edge between wakefulness and sleep, the line in memory where childhood fades into story. Each horizon arrives not as a failure of reach, but as a shape that holds the next shape. The ocean's rim does not keep a boat from leaving. It assures the sailor that navigation has meaning. A page's white margin does not forbid words. It gives the paragraph breath. The cosmic horizon does not forbid the future. It frames the present so that care can find it. At the end of the thought, a question breathes. If horizons are frames, what image is being framed? If limits are kindness, to whom is the kindness offered? No answer comes, only the line itself remaining where perspective places it, always retreating, always present. In its constancy, something like trust appears. The world, simulated or not, holds the shape of attention, and attention learns to hold the shape of the world. The quiet returns like tide around a stone. Questions move with wider spacing. The room, the night, the breathing world, each settles into a stillness that lets faint patterns gather. Even in stillness there is motion. The planet turns. Cooled, air sinks along walls, starlight that started before language meets paint and skin as a domestic hush. In this slower register, speculation loosens into a wondering presence. Inquiry continues, but its stride becomes walking rather than running, listening rather than reaching. If existence is hosted by code, the code hides inside ordinariness. A kettle whispers. A leaf turns on its stem. A street lamp wears a halo in mist. Each small scene contains an ocean of constraint and generosity, rules so reliable they disappear into trust. The cup remains a cup. The floor holds. Dusk becomes night without drama. Such reliability sometimes takes the name of natural law when the world is treated as given, and architecture when it is treated as made. The names change. The gratitude does not. Stability is not boredom. It is shelter. From this shelter an ethics takes shape, not as decree, but as symmetry. If beings share a hosted stage, whether the host is atoms or algorithms, courtesy becomes a physics of its own. Conservation of gentleness. Invariance under change of viewpoint. One could imagine Noether smiling at the form. Where a value remains the same while perspectives rotate, there a conserved quantity appears. Kindness keeps magnitude even as coordinates shift. Care looks less like a sentiment draped over a neutral. Machine and more like the machine's most elegant solution to the problem of many lives together. The pace drops another degree. The mind notices itself noticing, then notices that the noticing relaxes. Self-reference blurs like a reflection on a lake, present but moving with the wind. This is not a negation of thought. It is the recognition that not all truths arrive as propositions. Some truths come as textures, the weight of blankets, the barely audible traffic a few streets away, the memory of salt air that lives in bone mineral and breath cadence. If a simulation runs and awareness rides its currents, then one of its intended outcomes might be this, meaning that becomes felt before it is stated. Under such light, the grand frames of deep time and cosmic architecture pull near. Silurian mudstone and zircon clocks, the microwave background's faint embroidery, the neutrino wind, the nesting of realities that may sit inside others. Each becomes a kind of weather in which attention lives. Weather matters not only as cause but as climate. It inclines style and speech, favors patience over panic, fosters economies of care. In a cosmos framed by limits that are also invitations, the climate seems to reward slow-looking and steady hands. The narrative that began. as what if becomes a question content to remain a question. Not all programs compile to single outputs. Some compile to practices. In a world that may be simulated, the practice that suits is a gentle empiricism. Look closely, love repeatability, revise without resentment, protect the experiments that require trust, friendship, learning, the long work of mending. None of this depends on whether the substrate is carbon and water or lattices of qubits cooled to quiet. Reliability and tenderness feel like the winning heuristics either way. Gratitude rises for opacity. Not every mechanism must be open to be worthy of confidence. A heart continues in sleep without the sleeper naming sinoatrial nodes. A sunrise consoles without anyone recalling the phase function of scattering. If the scaffolding of existence wears a veil, the veil may be part of the gift. It lets meaning form at human scales with human rhythms. Excessive machinery in view can be its own glare. A dimmer switch set by care makes the room habitable. So, too, perhaps, the world. Purpose steps carefully here, no longer a demand for verdicts but a curiosity about fit. What sorts of lives fit well inside a reality that is at once lawful and possibly made? The answer arrives in simple close. Lives that return attention to where it is, that learn the names of near things, that repair more than they consume, that keep company with the vulnerable, that plant shade they will not need. Whatever the substrate, these habits appear to lock in coherence with little waste. Beauty might be the algorithm that finds low-cost alignment between many minds and one world. If there are maintainers somewhere, their speech, if it comes at all, likely arrives in the stable dialects: symmetry, conservation, continuity amid change. To that grammar, a few idioms join themselves: laughter loosening fear, meals synchronizing heart rhythms, music threading timing across different bodies, until a common tempo appears. None of this violates physics. All of it looks like a soft optimization, shared form found without expensive negotiation. Breath remains as metronome. Inhale gathers. Exhale releases. Between the two, a brief pause opens like a tiny horizon, a place where choice can rest before it moves. In that pause, the scale of cosmos or code becomes bearable. The question does not insist on an answer. It makes room for one if it arrives, and also for many if they arrive differently for different minds. Patience begins to look like the form of intelligence that best matches the world's restrained generosity. An image leans forward, then settles back. A shore at night, a long, slow tide, the sky with its patient freckles, the dark line where sea becomes sky and neither is fully separate. The horizon remains, and within it the particulars keep their humble work. Crabs stitching tracks in damp sand, a buoy light keeping time, distant engines that sound like weather beyond a headland. The world holds both the suspicion of code and the certainty of presence. Either way, it is a place where meaning has room. The quiet does what good frames do. It recedes until only the scene shines. Attention, rested, sets the question back on. The table like a seashell. Nothing solved, everything softened. The room holds, the tide keeps. Somewhere a system hums, somewhere else a star cools. Here, breathing continues. Here, night offers its patient hospitality. A thought remains, almost. A blessing, whatever the architecture, may awareness meet it with care. And so the question fades like a tide withdrawing. What if Earth is just a simulation? Perhaps it is. Perhaps it is not. The answer lies beyond reach, but the wonder it awakens remains. The spiral has carried us outward and inward, through galaxies and fossils, through paradox and silence, and now it returns us gently to the present. Night holds this moment softly, without edges, without urgency. The question rests. The silence deepens. The thought slows, like a river spreading into a still lake. The questions soften, no longer reaching outward but folding inward, dissolving into quiet. The night stretches wide, the stars resting in their silence, the earth turning with patient steadiness. Whether this world is simulation or cosmos, illusion or truth, it is enough simply to be here, to breathe, to drift, to rest. Darkness deepens, not as absence, but as comfort. It cradles like an ocean, vast and gentle, carrying every thought, every wonder, every fragment of self. The air is still. The body grows heavier, sinking into quiet. Beyond the horizon, galaxies turn, silent wheels of light. Beneath the surface, the earth holds its memory, patient and enduring. Around you, time moves gently, not as a river, but as a breath, frame by frame, moment by moment. There is nothing to reach for now, nothing to solve, only stillness, only rest. Imagine the sky, infinite and soft, its darkness filled with stars, like seeds scattered across eternity. Imagine the ocean, endless and calm, its surface smooth as glass. Imagine silence itself, vast and timeless, embracing all things. Here, there are no edges, no boundaries, no need for answers, only presence. Let the body rest in that silence. Let the mind loosen its grip. The spiral of thought has slowed, the night has deepened, and all that remains is stillness. Whether real or simulated, whether eternal or fleeting, this moment is complete. The question fades. The silence remains. The stars wait, unhurried. The earth turns, patient. Breath by breath, you drift further into rest, carried by the dark, by the quiet, by the gentle mystery of being and of script. Sleep well.